If you're new to machine learning, linear regression is the easiest algorithm to understand and implement. In fact, this is the first algorithm you're going to learn at the very start of your machine learning journey. Even though it might seem like a big task, within this video, this concept has been covered in a way that even a high school student can understand it easily. For starters, let me help you visualize what linear regression is all about. Let's say I have some data on the heights and weights of a few people, and I want to use this same data to predict the possible weight of a new person provided his height. Now, from this given data, we want to find a pattern that allows us to predict the weight of a new person for a given height. This makes our weight column the target variable and the height column as our input variable. Now, how can we imagine the relationship between these two features? Simple thing, we can plot them and understand their relation. Now, the simplest way to find this pattern is to assume a straight line relationship between height and weight. This is also called linear regression. The line follows the formula y is equal to alpha into x plus beta. Here, y is a predicted weight or predicted feature. X will be the height. Alpha is the slope of the line. It shows how much weight changes with height. And beta is the intercept, that is where the line starts. To make the best predictions, we need to find the values of alpha and beta so that the line fits the data as closely as possible. Now, what do we mean by this? Basically, the line should try and touch maximum of the data points. To achieve exactly that, we will minimize the difference between actual and predicted weights. Okay, this might sound a lot, but it's not. Let me hand over the proceedings to one of India's best data science trainers. He's right now leading the AI development team in one of the world's renowned fintech companies. And after he's done teaching, I am 100% sure you will never have to retouch upon this concept of linear regression.
Imagine you have a data set like this. You have weeks and sales, right? So week, W-E-E-K, week. Okay. This is the first week, the second week, the third week, the fourth week, and the fifth week. Example. You have 5 weeks. Okay. And the number of cars you have sold so far is like this, right? So the number of cars you have sold could be n number, right? So you have, let's take it like this, right? You have week in one of the variables and the number of cars you have sold so far in those weeks could be 2, 4, 5, 4, 5, some numbers, right? This is the data that has been given to me. Sir, can we mathematically understand in depth how does linear regression work? What does it actually do? And how does it make our life easier? Okay. In order to understand how linear regression works, first we need to plot this data. Okay. We need to take the data and we need to plot it in the XY graph. How do we do that? In a very simple sense, I'm going to take the variable like this. I'm going to take a straight line and I'm going to pass it like this. Okay. I'm going to have this. So this is my X axis and this is my Y axis. Okay. I'm going to point it out like this. So what is going to be my X axis? Will week be on the X axis? Can I say this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Can I say it like this? This is the 5-week data. So this is 5, week is X. Okay. What is going to be my Y? The number of cars sold. So can I say this is 1, 2, 3, 4, and 5. So 0, 1, 2, 3, 4, and 5. Anybody has any confusion in what graph did I plot? No, right? It's a simple graph. Nothing complicated. Very good. So in the first week of my graph, how many cars did I sell? I sold 2 cars. So can I have the red pointer point like this? Good. In the second week, I sold 4 cars. So this is 4 cars. In the third week, I sold 5 cars. Okay, so I sold 5th car like this. In the fourth week, I sold 4 cars. So this is 4th car again. And in the 5th week, I have sold 5th car or 5 cars. So, like this. Is this the data that has been given to me with the weeks versus the car sold part? This is the data that has been given to me. Okay. My people let me ask one question to all of you. Isn't it possible that there is infinite number of lines possible for this particular data? Meaning a line like this is also possible, this is also possible, this is also possible, this is also possible, this is also possible. Meaning to solve this problem, infinite number of lines are possible that will pass through the data point. Agree or disagree? I want to identify which line is the best line. Which line represents the best line for this particular data? In the previous example, I said line will pass, but what line? Which line? How do we identify that? We don't know anything. So in order to solve this problem logically, isn't it best to first understand where the line would pass from? Meaning, I'll give you guys an example. Listen to me. Suppose I have a point like this, a single point in a three-dimensional space. Is this line possible in a 3D space? Is this line possible? Is this line possible? Is this line possible? Is this? Basically, infinite number of lines are possible through one single point. Yes or no? Okay. But will the point move if I fix the point? Meaning, if I tell you this is the fixed point, the point won't move, correct? Only the lines are possible through that point. Agree? Yes or no? Okay. So listen to me. Can I not do one thing that is a guaranteed good point? I mean, the point that I'm recommending right now is a good point. What do you mean? In your x-axis, what is the mean of your x-axis? Can somebody tell me what is the mean of x-axis? Basically, the mean x bar of mean and x bar or y bar of this. What is the mean of x-axis? Is it going to be 3, the number 3? And what is y bar? What is the mean of y bar? 4. Agree, disagree? The minute you plot the data, the first thing you should do is take the mean and take the mean of x and take the mean of y. So can I say that the mean of x is 3? So it is going to pass here. I'm going to take a different color. Give me 1 second. I'll choose purple. I'll choose peach. Yeah, peach is good. Okay. So control Z. Give me 1 second. Is this the mean of x-axis? This peachy line that you see? Very good. What is the mean of y? Is this the mean of y? The minute you took the mean of x and mean of y, did you get a point for reference where the line should pass from? The minute you took the mean of x and the mean of y, you kind of got a reference via which a line could pass. Agree, disagree? But in this scenario also, listen to me. In this scenario also, isn't this line possible? Isn't this line possible? Isn't this line possible? Oh, it's complicated. So many lines are possible, but it's okay. We'll solve the problem one step at a time. Is this step clear to everybody? Take the mean of x and the mean of y. Step number 1. Take the mean of x and take the mean of y. Okay. Now, what you need to do is this. Okay. Your weak data, I'm going to take it as x. So what is the x data that has been given to me? 1, 2, 3, 4, and 5. Everybody agrees this is my x-axis data? Very good. What is the y data? It is 2, 4, 5, 4, and 5. Okay. This is my x-axis data and this is my y-axis data. Okay. What you need to do right now, the minute you calculate this part, x and y, so can we take first data point and try align with connect points? You will calculate something called x minus x bar. Hey, what is x minus x bar? Is this data point called x? This particular data point called 1 minus 3. From the perspective of 3, I want you to understand from the perspective of the number 3. Is this number 1 called x value and this is the x bar? This point is called x bar and this point is called y bar, yes or no? So basically, aren't you calculating that 1 is deviating from 3 by how much? 2 is deviating from 3 by how much? 4 is deviating from 3 and 5 is deviating from 3 by how much? Are you calculating this exactly? Yes or no? So tell me, x minus x bar meaning 1 minus 3. What is 1 minus 3? What is 1 minus 3? Minus 2. Very good. What is 2 minus 3? Minus 1. What is 3 minus 3? 0. What is 4 minus 3? 1. What is 5 minus 3? 2. So tell me, from the mean value, is this 1 point not in the negative 2 direction? Isn't from the mean this point 2 in the negative 1 direction? From mean, the mean itself is at 0 distance, meaning it is within calculation of itself. Then this number at 4 is 1 positive distance and this number to 5 is a 2 positive distance. Did it not give me the spread? The information, not exactly spread, but did it not give me the information of the deviation I have in the data? Minus 2, minus 1, 0, 1 and 2 with the number format. Is everyone clear? We kind of got the idea of how much is this part. Okay, because you did this with x, don't you need to do this with y also? So you need to calculate something called y minus y bar. Y minus y bar. So tell me, what is 2 minus 4? What is 2 minus 4? Minus 2. What is 4 minus 4? Is it 0? What is 5 minus 4? Is it 1? What is 4 minus 4? Is it 0? And what is 5 minus 4? It is 1. Is everybody clear what we did here with the calculation of x minus x bar and y minus y bar? What did we do with this? Why did we do it? To understand how far off my data lies from the actual mean value. Are we clear? Are we clear until here? Okay, good. The next thing that we do, okay, is there any reason to take x equals to 3? What you have to do next is x minus x bar, the whole square. You know why should you take the whole square? Because isn't minus 2 and plus 2 cancelling each other out? If I want to add them together, will I be able to add them together? Will I be able to add them directly together mathematically? The minus will nullify the plus value. Agree or disagree? So that the nullification does not happen, what do? We take x minus x bar the whole square. Doing squaring of a number, what does it make sure? That the number is always positive. Agree, disagree? If you take minus 3 and if you square it, won't the answer will be 9? And if you take 4 square, the answer is 16. So squaring will make sure that the number is never negative. So nobody will get cancel each other out, right? So what is x minus x bar the whole square? Minus 2 square. Can I say that is 4? Minus 1 square. Can I say it is 1? 0 square. Can I say it is 0? 1 square. Can I say it is 1? And 2 square. Can I say it is 4? Yes. Now, if you take the summation of all the values, what do you mean by summation? Addition of all the number. So tell me, what is 4 plus 1 plus 0 plus 1 plus 4? 8, 9, 10. Can I say it is 10? Can I say that the summation of x minus x bar into y minus y bar is this? Okay. Until here is everybody clear. Until here is everybody clear. The next thing you calculate is what we called as x minus x bar into y minus y bar. Now listen to me carefully. Can I say that this data point and this data point distance is called as x minus x bar? From this data point to this data point is called x minus x bar. Now listen to me carefully. Listen to me carefully. Can I call this also x minus x bar? This distance can be called as x minus x bar. Yes, good. Can this distance be called as y minus y bar? If I multiply x minus x bar into y minus y bar, essentially what I'm doing is, this is x minus x bar, this is y minus y bar. Multiplying them together gives me this answer. If I have an area of a rectangle, length into breadth gives me the entire area. Yes or no? This point, this line is nothing but x minus x bar. This line is y minus y bar. Am I not doing x minus x bar into y minus y bar? If I do x minus x bar into y minus y bar, can somebody tell me what is x minus x bar? Is it minus 2? Is the answer x minus x bar going to be minus 2? Yes or no? Multiplied by, what is y minus y bar? Minus 2. What is the answer? Is it 4? Very good. X minus x bar is minus 1. Multiplied by y minus y bar is 0. Is the answer 0? Okay. What is x minus x bar? 0. What is y minus y bar? 1. Is the answer 0? What is x minus x bar? 1. What is y minus y bar? 0. Is the answer 0? What is x minus x bar? 2. What is y minus y bar? 1. Is the answer 2? If you sum the numbers together, 4 plus 2, what is the answer? 6. Are you clear so far? What did you uh, do here while the calculation of this x minus x bar, y minus y bar? You have a line equation called y is equal to mx plus c. Yes or no? This is the line equation. Everybody agrees? Do you know the value of m so far and the value of c so far? Are you clear with the value of m and c? The answer is no. Isn't this the first thing you need to calculate? What is the m, what is the c, so that we can find out the line that can cross? Okay. To calculate the value of m, to calculate the value of m, to calculate the value of m using mathematical derivations. Do you understand what is derivation? You start with the base equation, you solve, and you get some answer. So, mathematically speaking, to get the value of y-intercept, or sorry, to get the value of slope, the formula is summation of x minus x bar into y minus y bar divided by summation of x minus x bar the whole square. Do we have the values for this? What is the value of summation of x minus x bar into y minus y bar? What is the answer? Is it 6 divided by summation of x minus x bar the whole square? Can I say it is 10? So the answer is 0.6. Did you just get the value of m, the slope of your line? We just calculated the slope of the line. Now listen to me carefully. Sir, how did we get this formula? Did someone calculate it? Yes. Somebody has already calculated this using mathematical derivation. If you want, so first of all, I don't think you should learn derivations, because somebody has taken enough effort to solve the derivation. Me teaching you the derivation is only going to take time, but it is not going to be important for you to know. What's important for you to know is to remember the formula. I can teach you derivation also. It's not a very complicated thing. It's a simple mathematical process. But the problem is that derivation will have no importance to you. Am I making sense? What formula it is, you need to understand that clearly. How you arrived at it can always be learned eventually over a period of time. But first, you need to understand what is linear regression, how it is applied, how can I practically implement it, then giving your energy to how did the derivation occur, who wrote it for the very first time, what is the history. I think you should focus on your priorities slightly differently. So did you understand why I wrote down the formula straight up for you so that you don't get confused? It is arrived using a derivation. This mathematical derivation is slightly complicated, slightly simple, but we have the formula. Okay. Here we are squaring the number and denominator. Yeah, I mean, This is the summation value. We are not squaring anything. It's summation of x minus x bar into y minus y bar by the summation of x minus x bar, the whole square. This will give you the y-intercept. The logic is pretty simple, but in the derivation, you will see why we do the division, because this goes on the left side of the equation. So we put it in the bottom. Okay. Anyways, this is the value of y. Now, between y is equal to mx plus c, what did we calculate? Did we calculate the value of y? It is now calculated. But do we have the value of c? No, we don't have the value of c. So to calculate the value of c, how do we calculate it? The formula to calculate the value for c, you have to use this equation. Y bar is equal to mx bar plus c. Now tell me, in this formula or in this equation, do we have the value of x bar and y bar already given to us? What is the value of x bar? X bar is equal to 3 and y bar is equal to 4. Yes or no? So you have this equation called y bar is equal to mx bar plus c. Okay. To calculate slope of any line, mathematically, you have to calculate the delta, the difference. Meaning, if you have a line here, if you have a line here, right? This difference in y and this difference in x will help you calculate this. And while the derivation of linear regression was done, right? So पहली चीज क्या है ना, हर फॉर्मूला मैथमेटिकली सेंसिबल हो ये जरूरी नहीं है. लेट मी आल्सो टेल यू व्हाई. आप पहले सुनिएगा ध्यान से और समझने की कोशिश कीजिएगा, और फिर मेरा तर्क समझिएगा कि मैं क्यों ऐसा कह रहा हूं. एक मैथमेटिकल डेरिवेशंस में क्या होता है, जो डेटा होता है, जो नंबर होता है, वो किसी फॉर्मेट में होता है. जैसे आपको एक एग्जांपल देता हूं मैं. हमने इनिशियल एग्जांपल जब किसी डेरिवेशन का लिया, तो वो डेरिवेशन में हमको बहुत सारे अजम्पशंस लेने पड़ते हैं. लेफ्ट हैंड साइड, राइट हैंड साइड को 10 से डिवाइड कर दिया. लेफ्ट हैंड साइड को लॉगरिदम, नेचुरल लॉगरिदम से डिफरेंट बेस लॉगरिदम में कन्वर्ट कर दिया, क्योंकि वो नंबर्स मैच नहीं हो रहे हैं. तो क्या होता है, इवेंचुअली हम किसी डेरिवेशन को जब स्टार्ट करते हैं, स्पेसिफिकली ये लीनियर रिग्रेशन की जो डेरिवेशन है ना, आपको अगर मैं पूरा डेरिवेशन सिखाऊंगा तो आपको समझ में आएगा कि क्या हो रहा है. कि इनिशियली जब हमने स्लोप को लिया था, जो स्लोप का एक्चुअल फॉर्मूला है हम उसी को कंसिडर करते हैं. बट इवेंचुअली जब हम इसको ना सॉल्व करते हैं, मतलब सॉल्विंग फॉर द लेफ्ट हैंड साइड एंड राइट हैंड साइड, जब हम सॉल्व करना स्टार्ट करते हैं ना, तो हमको रियलाइजेशन होता है कि मे बी लेफ्ट एंड राइट में ना कुछ और ऐड करना पड़ेगा ताकि वो बैलेंस आउट हो जाए. करते 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 जाते हैं, तो इवेंचुअली वो जो फॉर्मूलाज हैं वो थोड़े डिफरेंट फॉर्म में कन्वर्ट हो जाते हैं. फिर हमें क्या करना पड़ता है, एम के लिए ऊपर वाली वैल्यू को नीचे लेके आना पड़ जाता है. तो क्या हो जाता है कि आपका ये जो समेशन ऑफ एक्स माइनस एक्स बार द होल स्क्वायर है ना, ये लेफ्ट हैंड साइड में आता है, और ये जो समेशन ऑफ एक्स माइनस एक्स बार ये राइट हैंड साइड में आएगा. तब क्या होगा, ओवरऑल जब हम सॉल्व करना स्टार्ट करते हैं ना, तो ये समेशन वैल्यूज जो है, जो ये आपको ये फॉर्मूला दिख रहा है, इट स्टार्ट्स सॉर्ट ऑफ फॉर्मिंग इनटू दिस पर्टिकुलर फॉर्मूला. जो आपको ये दिख रहा है ना, ये इस फॉर्म होना स्टार्ट होता है. एक काम करता है, व्हाई डोंट वी सॉल्व द डेरिवेशन आल्सो सामने ही. इफ यू रियली वांट टू अंडरस्टैंड मशीन लर्निंग, yeah, the point is, if you want to deeply understand machine learning, like when I'm talking about deep, because here is the thing, when I started machine learning, right, I have implemented each algorithm, every algorithm in machine learning from scratch. I have done that. That is when my knowledge in machine learning increased 10 times. Because when you do not use any packages, any libraries, understand the core mathematical concepts, you should be able to like build anything, because you now understand the basis behind it, right? Just like that, learning the core mathematics is important. The reason I am not going ahead with the derivation and explain you logically how did we arrive at this conclusion is because it will end up taking a lot of time. Number one. Number two, the mathematical reasoning that it takes to arrive at this solution is also going to be very, very complicated for few people. So that's why I said, if you start with machine learning right now, you guys are just starting with machine learning, right? Focus on how to apply machine learning, then learning the foundational logic. But because if the question is, how did we arrive at this conclusion? We can always go back and learn the derivation also. So it's up to you guys. I mean, if derivation is also something that we can look at, we can also look at this. The derivation will make sense. why are we taking this area x minus x bar the whole square will start making sense because it is directly related to residuals. So now that we've understood, right, slope of the line using the data point or variable, which is one independent, one dependent, we are able to calculate the equation, slope using this particular formula. Now that we've understood how we calculated that using the slope, the next thing that's pending is for me to calculate the y-intercept. Okay. Because y-intercept cannot be calculated directly, I need to manipulate my equation slightly differently, like y is equal to mx plus c. Because we don't have m and we don't have c, right? We don't have c, sorry, y and x. We calculate y bar and x bar. X bar is already given to me as 3 and y bar is already given to me as 4. So tell me, what is the value of y bar? Is it 4? Is equal to, what is the value of m? 0.6. What is the value of x bar? Is it 3 plus c? So mathematically, if I solve this, 4 is equal to, what is 0.6 into 3? Is it 2.2? Okay, that's good. 2.2 plus c. Now, listen to me. In mathematics, when you jump equal to signs, you convert the sign from positive to negative or negative to positive. Meaning, if this 4, if this 2.2 needs to jump to the other side of the equal to, what will it become? Will it become 4 minus 2.2 is equal to C? Yes or no? Whenever you change the number from one part of the equation to the other part of the equation, if it is a, so what will be the value of C? What will be the value of C? 2.2. Wait, 0.6 into 3 cannot be 2.2. I don't know if it makes sense to me because 6 threes are 18. It should be 1.8, right? If I'm not wrong, 6 threes are 18. Point difference is 1.8, right? Yeah, this should be, I think the difference is 1.2.2. I think this is what you mean. Yeah, I think I got the concept. Okay. This is 3.2. Yeah, T is 2.2. Exactly. So tell me, did you get the equation y is equal to mx plus c? And now you have an equation for the line 0.5 into x plus the value of c will be 2.2. Did you get the line equation for your data using the steps that we have done so far? We got the equation called y is equal to mx plus and we got the line. But our job is not yet done. Until here, is everyone clear? Until here, is everybody clear? What exactly did we do to solve until here? Everyone got the concept until here. 0.5 or 0.6. But there is so much more to achieve. Meaning, you got the line equation 0.6x plus 2.2 something, something, something. My people, based on the linear equation graph that you see that I have plotted for you like a while ago, which is this. Okay, give me 1 second. Let me copy the graph. Give me 1 second. Let me just go ahead and copy this and paste it here. Give me 1 second. Copy this and paste it towards the bottom. My people, we got the equation of the line equation as y is equal to something, something like this. Like, so we got a line equation that passes the data like this. But observe very, very carefully that the distance between your actual data point, is this my actual data point? AP is my actual data point. AP is the actual data, the real data. And the line is the prediction. Agree or disagree? This is my predicted data and this is my actual point and predicted point. Can I say it like this? Do you see there is some difference between it? Some distance, some error? Yes or no? This error exists here also. This error exists here also, here as well, and here as well. There is some distance between this, and this. The data points are distance. This distance or difference is called as residual. What do we call this? What do we call this? Residual. Tell me, the point is very simple. When you make linear regression line happen, or when the linear regression line has been calculated, do you want the distance between data point and the actual point To be the least as possible or to be the maximum as possible? What should your intention be? Your intention should be to minimize, right? Your intention should be to minimize the residual, but your life and your job is not that simple. Let me explain why. Let me explain why this is not simple. Listen to me carefully. I'm going to erase these data point, okay? The line point, and I'm going to show you guys an example. Mathematically, also sensibly, it should make sense to you. Okay, give me 1 second. Let me copy this graph and paste it so that I don't ruin the graph. Give me 1 second. Why am I not able to copy? Okay, this is the copy, is it? Okay, fine. Yeah. So listen to me carefully. I'm going to erase the middle line for a second so that you guys don't get confused. Okay, X bar, Y bar, I'm going to remove. My people, now we have a line that passes through the data like this. Okay, it is passing through the data point like this. Listen to me carefully. And it is passing through the line like this. Like this is the line that we have calculated. Okay. This is the distance between the predicted data point. This is the predicted data point, and this is the actual data point. Okay. So tell me, isn't this data point the data point which is predicted versus this is the actual data point? This is the data point which is actual, that is, this is predicted, that is actual, this is predicted, that is actual, this is predicted, that is actual. So listen to me carefully. This is the error, also called error number one. Can I call this difference as error one E1? Yeah. Can I call this error as E1? Okay. Can I call this error as E2? Can I call this error as E3, this error as E4, and this error as E5? Can I call this E1, E2, E3, E4? So the best possible line for me to claim that the line that I have has the best fit, it's fitting the data points in the best possible way. So shouldn't that be possible that E1 plus E2 plus E3 plus E4 plus E5, this number should be the most minimum number as possible? Yes or no? The number E1 plus E2 plus E3 plus E4 plus E5 should be the most smallest number possible. But the problem here is some data points are following in the positive direction, meaning in the bottom, and some number are at the top. So isn't it possible that E1 and E2 will also cancel each other out because the directions are different? Does that make sense? See, from this data point to this red data point, it is in the negative direction, but E2 is in the positive direction. So if I don't square them, won't they also cancel each other out? And the actual answer will be terribly wrong. So rather than combining E1, E2, E3, E4, E5, do we not take E1 square plus E2 square plus E3 square plus E4 square plus E5 square? Agree, disagree? Now listen to me carefully. Listen to me carefully in a most simplistic sense. Okay. If I take this line and rotate it a little bit more, the line that we have calculated it just for practical purposes, just to test something. Can I rotate it a little to the left and a little to the right? And when I rotate it 2 times to the left, one left, one right, I got the value of error, ERROR, TOTAL, total error as 1.6, 1.2, 1.9, and 2.3. When I rotated the line, which line gave me the least amount of error? In this 4 rotation that I did, 2 to the left, 2 to the right, did this give me the least amount of error? That line is your best fit line. Did that logically make sense? Did that logically make sense? Okay. Can I show you an example? Can I show you an example practically to show you how in reality in linear regression, how it works? You guys want to have a look? Have a look at this, okay? Linear regression, best fit line, okay? Fit line. Look at this, my people. This is my linear regression data. Can you see what's happening to the line? Did you see what happened? Did you see what happened? See, I'm going to rotate the line, okay? I'm rotating the line. Is the error increasing and decreasing? Are the errors increasing and decreasing because of the rotation? Have a look at this also. See, this is the best fit line. Do you see the mean of X and mean of Y? Do you see the mean of X and mean of Y? We took the red color line. On that point, are we rotating the line that we just calculated Y is equal to mx plus c? When the rotation when we do that rotation, isn't it possible that we can get the value of multiple different error types? And whichever error has the least possible error, that line is the best fit line. Did you understand the logic behind how linear regression is able to calculate the least amount of error? And that line is going to be the best fit line for your example. Is everyone clear what we did in linear regression? First, we plotted the data. Then we took the X bar and we took the Y bar. Sir, we have to code for this. It's too long. The entire linear regression code is 15 lines of code. 15 lines without any library. Without any library, it's 15 lines of code. Do you think it's too much? Point being, first we plotted the data, then we took the mean X, mean Y. From that point, we passed the problem or we passed the line, and now we are rotating the line a little bit to check whether the data or the line is the best fit line. Did you get what exactly I was saying? What line rotation is showing exactly? Line rotation shows you the distance between the error. Meaning, suppose if this is the graph that I have, okay, this is the graph that I have, this is line number 1. Is it not possible for me to rotate the line slightly and have another line like this? If I rotate the line, the distance between actual data point and your prediction data point, does it not change? And your job is making all the errors together, E1 plus E2 plus E3 plus E4 plus E5, all the errors together. Don't we want a number, a value of the line where all the errors together is the least number possible? That is why you rotate the line. Rotate the line. The only thing you need to change in your equation is M, right? Because Y will remain the same. Or no? To rotate the line, what do you need to change? Both M and C, right? You need to change both M and C together for the line to rotate, right? So multiple values of M and multiple values of C will give you the answer. Isn't this like the initial guess of the line? The initial guess of the line, is it the best fit line? The first product you buy, is it the best product? No. We just made a guess on the Y, axis equation. We did that. But is that line the best fit line? Are you sure that is the best fit line? Can you be sure? No, right? In order for us to understand which is the best fit line, we take the line that we just calculated and we rotate it a little bit. Based on the rotation, whichever error value has the least error, that is the best fit line. Now, my question is, how many of you got this and how many of you did not get it? Let me take up a quick poll. How many of you got it? Yes, yes, yes. How do we calculate it? How do we do it? I'm going to teach you all of that. How many times to rotate? The higher you rotate, the better chances of best fit line it is. The higher you rotate or the longer you rotate, the better the chances you will find a best fit line. If we rotate, are we not changing the C 2.2 which we calculated? Yes, we calculate both the L, M and C, we change and we check for multiple C and M. Okay, let me explain. How do we rotate? How do we rotate? Let's understand. Let's understand the rotation. Is this my line with some value of M and C? Yes or no? You first please tell me that. Is M is equal to, is the value of M 0.6 and the value of C 2.2? Yes or no? If I want to rotate, this is the line, okay? This is the line which will give me this y M is equal to 6.6. If I want to rotate it by one degree, 1 point, increase M and decrease Y, can I do this? Or decrease M, increase Y, can I do this? Are you getting what I'm trying to say? This is my XY graph. This is my y point on which the line is plotted. And this slope of the point is 0.6. Make it 0.5 and make the intercept here. Will the line now rotate by some point here? Increase point number 1 by one more point, decrease the slope by 1. Will the line rotate now? Same thing, keep doing. Increase the point by 1 and decrease the point. Did you now rotate the point slowly, slowly, slowly by changing this decrement by 1, increment by 1? And now if you do the reverse operation, it will go in the opposite direction. Agree, disagree? Am I making sense in this part? At least in this part, 1.1 increase. Won't you be able to calculate for multiple values of y, like the line will rotate? This is the line equation that we calculated. Listen to me carefully. Based on the data, what did we do? Based on the data, what did we do? Did we calculate the y is equal to mx plus c equation? That was the first thing that we did. Yes or no? Y is equal to mx plus c was the first thing that we calculated. The line equation that you calculated, y is equal to mx plus c. How sure are you that that line is the best fit line? Can we be sure that the line equation that I calculated, y is equal to 0.6 into x plus 2.2. This is the line which is the best fit line. What do you mean by best fit? The line passes through all the data point in the most perfect way. Are you sure that this is true? Should you not validate that? We are not sure. Should we validate? The answer is yes. You need to validate. In order to validate, how do we validate if something is good or not? Mathematically, we need to have some foundation for it, right? How do we identify somebody is a good ranker, somebody is a bad ranker? Shiv Kumar, who spoke to me a while ago, is a Bihar topper. How do we know he's a Bihar topper? He must have gotten good score. His percentage would have been higher. The number would have been bigger. If the number is smaller, does it equally mean that the person did not score well? Yes or no? This is called mathematical quantification, meaning some number is trying to give us the idea. So tell me, suppose I have a line called line number 1. This is my line. This is the line. My people, this red color point, is it my actual data point? Is this the actual data point that was available in the data? Good. But using the line, did you predict another data point, which is your prediction? This point on this line is your prediction. This is not the actual data. This is your prediction. Yes or no? Can I say the distance between the prediction versus the actual value is -2? Example. For example, it is -2. Can I say this? Good. The distance between this data point, the red actual data point, and this data point is +2. The distance between the red data point and this data point is +3. The distance between this data point and this data point is -3. And the distance between actual data point versus this predicted data points is -2. Example. So far, the total error in the program is nothing but the difference, right? Difference between the actual and the predicted is what the error will be, right? So -2 +2 +3. Okay, so -2 +2. Let me expand it and write this. Okay, so let me say -2 +2 +3 -3 -2. If I add them together, will this not be the actual difference, the error in my program? Isn't this going to be my error? But -2 will cancel 2, +3 will cancel 3, and the answer is -2. Is the answer actually -2? No. Even if they are not equal, even if the numbers are not equal, okay, the problem here is mathematically, if this number was -2 and this was -2.1, won't the answer be 0.1, which is also not correct? The numbers don't need to be equal, but they cancel each other. They take a portion of each other. We don't want that to happen. So rather than taking errors like that, don't we square them, the errors? Yes or no? So rather than taking the answer like this, if I want to quantify the number, Can I not take minus 2 square plus 2 square plus 3 square plus minus 3 square plus minus 2 square? The answer will be 4 plus 4 plus 9 plus 9 plus 4. Can I say now this will be some number that represents the error? Are we clear until here? Dipankar, even if it's not equal, it does not matter, my dear, mathematically. It won't make difference also. If one direction it's minus 2, other direction it is unequal number, errors will still get added together, right? At the end of the day, you're adding the errors together. It does not matter if you have 10 rupees, 15 rupees, 19 rupees. It does not matter what number you have. The errors at the end of the day are getting added together, but you're trying to nullify them. I am not nullifying them. I am taking the difference between the actual data point and the predicted data point and square them. I am saying that you should square it. I am not saying nullifying it. I am saying square it so that nullification does not happen. I know positive and negative predictions. That's why I'm saying squaring them will convert it into a positive number, and all the positive numbers you can add together. You got, this is a very simple thing, my dear, not a very complicated thing. Minus 2 and plus 2, if you square, minus 2 square is 4, plus 2 square is 4. If you add them together, did you get the value 8? 8? Agree, disagree? Yeah, okay. Even if you have 15 points, 1500 points, whatever points you have, the distance between the actual versus predicted data point, you need to square them in order to get the error. So tell me, what is 18 plus 12? What is 18 and 12? So 8, 9, 10. This is going to be 30. So did we get the error? The total error using the line is 30. Yes or no? We are not nullifying anything. We are trying to get some number. Okay. Now tell me, I'm asking a very simple question. Very simple question. Are you sure this is the best possible line in the entire data that you have? No. If I rotate the line slightly to the bottom, isn't it possible that that total error now will be 29? Slight rotation gave me the error as 29. And we want the error to be as minimum as possible. So will you choose line number 1 or will you choose line number 2 as the best fit line? If this is my line, okay. Do you guys know that in mathematics, you can take a range between 0 to 10? I can take 0, 1, 2, 3, 4, 5, 6, 1 point at a time. This also is possible between to reach 0 to 10. Okay. 0 to 10 can be reached by 1 unit distance, meaning between 0 to 10, I can reach 10 by exactly how many steps? 10 steps, correct? Taking one at a time. Agree? Yes or no? If I want to count from 0 to 10, but I want to take one step at a time, so can I take from 0 to 10, making only one step at a time? I'll be able to reach 10 times. But same 0 to 10, you can reach in 20 steps by taking 0 0.5, 0, 0 0.5, 1, 1.5, 2, 2.5, 3. Can I say you can reach from 0 to 10 using also 40 steps by taking 0. I don't know, 25? How much to rotate? Should it not depend on how much you want to increment your MNC? Am I making sense? Your y is equal to mx plus c. Your value of m was 0.6 and your value of c.2 was 2.2. Your m can be 0.65, meaning 0.05 times your increment one step, one step, one step, one step, one step. Or you can also do 0.1. So 1, 1, 1, 1, 1. Does it not depend on the user how much you want to rotate? Does that make sense? And because it is a computer program, we can make it do millions of rotations. That line could be rotated in the positive direction and in the negative direction. And let me ask you a question. Let me ask you a simple question. Did we not calculate the mean of x and the mean of y like this? Did we not calculate the mean of x and mean of y? Should you even rotate it beyond this and beyond this? Meaning, should the line go beyond this point and beyond this point? It should be between the points, right? If it goes beyond, are you even calculating anything? I hope you got the concept. Did you get the concept of rotation? How exactly linear regression is able to do that? How are we able to find the best fit line? Exactly. Exactly. Thank you. Are we clear with what exactly is the definition of linear regression? How it is able to do it? It is a very simple machine learning algorithm that's able to do it. And based on that, and based on the best fit line, we will be able to make a prediction in the future because that line has the least amount of error. So if the prediction in the future is that for 4,000 square feet house, it is 2 crore, meaning it actually in reality is 2.2, but R isn't 2 crore nearer to 2.2, meaning with some error, we were able to very closely identify the answer. That is why linear regression is used. Concept of what is R square. Okay, my people, in linear regression, R square represents a very simple information, and that information is R square tells us how well the line predicts or fits the actual point, or how well the line predicts the actual point. This is technically more correct. So R square tells us, okay, R square tells us how well, how WELL, the line predicts, okay, predicts the actual points, POINTS, okay. R square is a way to tell yourself that your model is doing a good job, or your model is doing a bad job, or your model could do better. Okay. This is a way to quantify it to yourself. Now you can ask me one thing, sir, why don't we have a quantification already with something called residual error? We do. The problem is linear regression has a very big problem, and that problem is outlier. If you have a line of a linear regression where you have one data point here, one data point here, one data point here, one data point here, and one data point here, this is known as the best fit line. Okay, the red color thing is gonna be my best fit line. But by mistake, if your point is somewhere here, right, then your best fit line would go somewhere like this. So tell me, does outliers affect the output of your linear regression model? Does having an outlier create problems? Sir, 100% it will create problems. If you don't know, I'm telling you this right now. So removing outliers from your data should be an essential part of your EDA. Have you all heard of something called EDA? Has anybody heard of the concept called EDA? The full form is called exploratory data analysis. It's called exploratory, okay, data analysis. Are we clear? So now that we have spoken or learned about R square, what exactly is R square? Take a line. Listen to me carefully. Take a linear regression line. Okay. So for example, if this is like the y-axis and this is like the x-axis. Okay. If this is my x-axis and this is my y-axis. And suppose you have data points like 1, 2, 1, 2, 3, 4, 5, right? Like this. One. Suppose if you have a data point like that. R square, most simplest form I'll explain. Okay. It is nothing but the distance between and the distance between. Okay. There are two distances we will calculate. The actual value minus mean value, the estimated value minus mean value. When we did linear regression code, okay, when we wrote this graph in front of you, right? I'm not sure if I can copy this, but I'm gonna try my best. Give me one second. Oh yeah, I can. Control X. Yeah. Okay. You see this graph? We did this graph. Whoever does machine learning well, their level will be the best, is what I meant. You know what I think? Listen to me. Listen to me. Okay, listen, because this is a very important concept. Here's what I think. I think all of you need to make a Google sheet. A Google sheet. In that Google sheet, just write down your name and your address. Your name and your address. And what I'm going to do is I'm going to have a deal with Swiggy and I'm going to be like, look, 7 o'clock, I start my class. 6:45, I want you to send tea or coffee based on whatever preference you have to all my students so that they wake up. But before delivering the copy, take a hot water and just like on their faces so that they are up. Yeah, we'll speak about that. I think this is a good startup idea as well. It's a very simple idea. I am teaching you the concept of R square. R square tells you how good your model is or how good the estimation. What do you mean by estimation? Prediction only, right? Estimation is prediction only, right? You have some actual data point. You having actual data point is called ground truth. Remember, in machine learning, this is a very important term. Ground truth. GROUND. TRUTH. Ground truth means your actual data. It is a very important technical term. Just like how in marriage, I am sorry works every time. It's an important keyword. Ground truth is an important keyword. It represents all your actual data point. Okay. So now your ground truths are your actual data points and your line is the estimated data points, basically the one that you have estimated, right? So tell me, do you have something called the Y bar? This thing is called as the Y bar, the mean of the Y, the Y mean. Okay. On this particular plane, what two things do you see? One is the Y bar and the other is the actual data point. Correct or not? There are two things on the graph right now. One is the Y bar and the actual data point. Can I plot a line, a regression line like this? So now what do you see? You also see the predicted line. Now there are three things on this particular graph. Make sense? Now there are three things in the graph. The distance between actual data point and mean. Listen to me. The distance between actual data point and the mean value. Is this the actual data point? The red dot? The distance between actual data point and mean. So can I say this is the distance between actual data point and mean? This is the actual distance between data point and mean, and rest is on the same tribe. So this distance is what we are calculating first, the actual distance between data point and mean. Yes or no? Good. Then the next difference we calculate is estimated minus mean. Meaning, can I say these is the actual data point, the red one, and the yellow one is the estimated data point. This is the estimated data point. This is the estimated data point. And this is the estimated data point. The next thing you do is you calculate the distance between estimated minus mean, estimated minus mean, estimated minus mean, which is this much. Okay. Estimated minus mean and estimated minus mean. Did you get what I'm trying to say? The distance between actual data point minus mean data point and estimated minus mean. And when you want to do their comparison, this comparison is what we call as R square. Are we clear? It's not a very complicated topic. Everyone got the concept, right? You got the concept very, very well. So tell me, Can I expand your knowledge now on how to do this mathematically? Again, I am not showing you how the formula has come up into picture, but like we have to take y-axis mean only because y is enough base for comparison. You got what I'm trying to say? Y is also an axis, which is a mean value. X is also a mean value. Taking from y makes more sense because you are doing y prediction. I hope you got what I'm trying to say. Your equation is y is equal to mx plus c, right? So y becomes a solid base. Okay. R square is the distance between the actual data point minus the mean data point. You compare against the estimated data point minus the mean data point. No confusion here, right? It's a comparison, simple comparison. It does nothing else. I'm going to show you mathematically what it does. Okay, good. I am going to take the X and the Y from the code. Give me 1 second. The X and the Y. Copy. Is this the value of X and Y that we have? Tell me, what will it mean if I do this? Y minus Y bar. What do you mean if I do Y minus Y bar? Is this line actual minus mean? The actual data point minus the mean is going to be called as Y minus Y bar, yes or no? This is simple logic. You guys must have learned that by now. So tell me, what is Y minus Y bar? 2 minus 4. What is 2 minus 4? 4 minus 4. 5 minus 4. 4 minus 4 and 5 minus 4. What is the answer, everybody? What is 2 minus 4 minus 2? What is 4 minus 4? 0. 1. 0. 1. Can I say this is the answer for actual minus mean Y minus Y bar? Can I assume my understanding is correct? Because the numbers could be both negative and positive, we don't want that. What do we do with those numbers? Whenever the number starts becoming negative, very good. So do we take Y minus Y bar the whole square? So does it become 4, 0, 1, 0, 1? Now, tell me if I sum the number up, if I calculate its summation, what will be the answer? If I sum them up, 4, 5, 6, 6. Let's calculate something called y hat. Y hat is nothing but, what was the equation that you got? What was the value of m that you got here? 0.6 and 2.2. 0.6 and 2.2. 0.6 into x. What is the value of x? 1 plus 2.2. Can somebody tell me what is the answer? 0.6 into x is 2 plus 2.2. 0.63 plus 2.2. 0.6 into 4 plus 2.2. 0.6 into 5 plus 2.2. Am I predicting the estimated data point here using the y hat? Yes or no? This would be 2.8. 1.2, 2.2. What? This should be 3.4, right? If I'm not wrong. Right? 4, 4.6. Yeah, that's true. And that would be 5.2, right? 4.6 and 5.2. I'm assuming this is correct because it is at a very standard difference. Is it correct? Is my y hat prediction correct? 2.8, 3.4, 4, 4.6 and 12, 5.2. Correct? Okay, good. Did you all understand what is y hat? Y hat is the estimated data point. Using the equation only we calculated the estimated, right? Using the equation only we will calculate estimated, correct? So tell me, my people, I have actually taken something called actual data point, actual point minus mean I have taken. What am I remaining with? What is remaining? What is missing here? Which point is meaning remaining? Estimated minus mean, correct? See, actual data point minus mean is taken. Estimated minus mean is not taken. What is your estimated value? Y hat. What is the mean value? Y bar. So what is the estimated value, my people? 2.8 minus what is the Y bar? Is it 4? What is Y bar answer? Negative 1.2. 2.8 minus 4 will be negative 1.2, correct? You know what? You do the hard work. 3.4 minus 4. 4 minus 4. I will write the answer. It is easy. Minus 4 and 5.2 minus 4. Come on, give me the answer for all of these. What should be the answer? Negative 1.2, negative 0.6, 0.6, and 5.2 minus 4 is going to be 1.2 because similar answers. Aren't these answers in plus and minus? Do we like answers in plus and minus? Do we like the answers in plus and minus? No. So what do we do? Y hat minus Y bar the whole E square. What is whole E square? Everybody, what is 1.2 the whole square? It becomes 1.44. What is 0.6? 6 twos are. Nah, it's not done like that. It's going to be 0.36. Yes or no? 0. 0.36 and 1.44. Now what do we do? If I sum the number, what answer do I get? What is the answer? If you sum them together, 3 point. Is it correct? Is the summation going to be 3.6, everybody? That's good. That's good. Once you have calculated this, your R square formula is very, very simple. Your R square formula is summation of Y hat minus Y bar the whole square divided by summation of what are you comparing it against? Estimated minus mean is compared against actual minus mean. What is the actual minus mean? The actual minus mean the whole square. So tell me, what is the number that we got? Is it 3.6 divided by 6? What is the answer? What is 3.6 divided by 6? What would be the answer? About 0.6. Remember one thing. R square is a number between 0 and 1. What is the number R square? R square is a number between 0 and 1. If your R square is closer to 1, the fit is good. If your R square is closer to 0, the fit is bad. What R square did we get? What R square did we get? Closer to 1. So what does it recommend? Is it recommend or is it recommending something that my fit is good? But R square has a problem. You know what is the problem? I'm going to show you what is the problem. R square formula. You are going to be very much confused when I show this formula, right? Have I taught you the formula like this? Okay. Did I teach you the formula like this? Y minus Y hat the whole square, Y minus Y bar the whole square. Is my formula different from this formula in what way? Copy image and paste it here. Okay. What's the difference in my formula and this formula? Please, somebody tell me fast. Nope. Look at the numerator and look at the denominator. Y minus Y hat. And here I have Y hat minus Y versus Y minus Y bar. Okay. Actual minus predicted and estimated minus mean. Okay. Two things. I'm also going to show you guys one more formula. Okay. I'm going to show you guys it like this. Okay. Give me 1 second. Copy image and paste it here. Is this visible to all of you? Is this image right there visible in front of you? Listen to me carefully. Do you see this thing called SSRES? SSRES. The full form of this is sum squared residuals. Residuals. And the third is SS tot. Sum squared total error. Okay. TOTAL. Now, I don't want you to get very much confused with this concept that, oh my God, what is this new thing? It's nothing. It's nothing. Literally nothing. Okay. The formula that I gave you, okay, the formula that I have given you, which is this formula, here r square is nothing but sum of squared residuals divided by sum of squared total. Sum of square residual divided by sum of square total. You have to think of it like this. In r square, okay, while calculation of r square can be expanded in multiple different forms, like sum of square residuals by sum of square residuals plus sum of square error. Okay, that becomes sum of square total. When you rearrange the terms, you get an answer like this: 1 minus, okay, summation of y minus y hat, which is the actual minus estimated, actual minus, actual minus predicted, which is y hat, and actual minus mean. When you say you're comparing, you're basically dividing one comparison with another comparison, and you're taking something called as a ratio. Now, I am going to ask you guys a very simple thing. Do you know what is the meaning of the word ratio in mathematics? Let me give you guys a very simple example. Very simple example. Tell me, if you had 4 chocolates and 2 people to share it with, per person will get how many chocolates? 2. Reverse the situation. You have 2 chocolates, but 4 people. How many will each person get? About 0.5. Agree, disagree? Okay. This number represents the power of the method, meaning when you divide a larger number by a smaller number, you get a number which is significantly different. When you divide a smaller number by a larger number, you get a significantly different result. What do I mean by that is, does the answer of the division represents the equal parts for that particular division? For 2 people, you get 2 chocolates. For 4 people, you're going to get this chocolate. Division of A divided by B will give you some value called X. B times X is always going to be A, right? X into B will always be A. It will always come back to A. The value X represents equal portions. Equal portions for the value at the top, or sorry, equal portions with the value at the bottom, meaning sum of squared total, right? You will get some answer called X. Has a relationship with this number. This X number represents the equality among the equation, or equality among the among this particular division. Meaning, whenever you take r square and the number is larger to 1 or closer to 1, whenever your r square is closer to 1, what does that represent with numerator and denominator? What should it represent? Under what condition will be the number closer to 1? If the numbers are closer to each other, or if the numbers are far away from each other, meaning you have a value called A, you have a value called B. Between A and B, if the number of A and B, if they are closer to each other, will that become 1? Or if they are far away from each other, will that number be 1? Please think and answer, okay? Please think and answer. If the numbers are closer to each other, meaning, let's take the example 3.6 divided by 6. 3.6 divided by 6. What is 4 divided by 6? Very much tell me, what is the answer? What is 4 divided by 6? This is not a very hard calculation. What is 4 divided by 6? 2 2s are 4, 2 3s are 6. What is 2 divided by 3? 0.67 approximately. What is 5 divided by 6? What is 5 divided by 6? 0.83. What is 5.5 divided by 6? 0.92. Let me ask you guys a simple question. When your sum of squared residual error, which is sum of square residuals divided by sum of square total, when both the errors are very close to each other, is your R square saying that the model is a good fit? Listen to me. But what does that mean in the graphical format? The closer the lines of estimated and minus mean or actual minus mean are, the better the R square. Meaning, when all the distance between the actual minus mean and estimated mean is as less as possible, the numbers will be more, will be closer to each other, and hence the R square will be bigger. You got the concept? If the distance between the actual minus mean and the estimated minus mean is as closer to each other, the numbers will be as closer to each other, and the R square will be equal to or closer to 1. And that will represent a good fit in the model. Did, did you guys get the logic behind it? You got the concept behind it, right? Why R square is preferred for the choosing or for the recommendation that my model is good or not. Are we clear? Is everyone clear until here? You guys got the concept? Okay. Now listen to me. Do you see this formula? Do you see this formula right in front of you called adjusted R square is equal to 1 minus uh, R square into n minus 1 by n minus p minus 1? You see this formula a lot? Okay. So just listen to me, okay? Just listen to me. If you do anything wrong in your house, do we get punished? I'm not sure if the kids nowadays or the parents nowadays even hit their kids, but yeah, I mean, I was the champion at my time, right? Like anybody used to just, but you do anything wrong, you get punished, right? In machine learning, this technique is called penalization. What do we call this? What do we call this technique as? Penalization. I have a very simple question I want to ask you. This question is going to come in your interview. It's going to be asked in your interview. This is not a 5-star. This is a 100-star question. My people, what is the difference between a machine learning model where you have A, B, C, and D and a target column? How many independent columns exist here? In technical term, they are called as features. Features. So from now on, do not call it independent column, call it feature. How many feature columns are there? 4. How many target column are there? 1. Correct or not? If I want to run machine learning on a model or on a data where the number of features, features, is 100 columns and the target is 1. Do you think that machine learning should have no problem in running 4 feature, 1 target, 100 feature, 1 target? Or do you think the machine learning model will get a problem? My question is, if the number of features increase, listen, this is a very important question I'm asking you. Trust me, this is very important. If the number of features increase in linear regression or any machine learning model, okay, not just linear regression, if the number of features increase, does that cause problem in the machine learning modeling? The answer is yes. The answer is 100% yes. I'll tell you why. Listen to me why. For the prediction of some answer, for the prediction of some target variable, I'll tell you why this is a problem. Listen to me. Listen to me. I'll tell you why this is a problem. Suppose you have a column called age. You have a column called salary. You have a column called blood group. You have a column called civil score. You have a column called DPDs, days past dues. Oh, XYZ, XYZ. And the target column is whether this person should be given loan 0 or should be given loan yes or no. Tell me, for the prediction of the loan, will the age column also will be like a person? Hey, you should consider me also for your prediction. Then there will be one more person called salary. Hey, you have to also consider me for the prediction. Then the background will be like, hey, I am also existent. Sibyl say, I am also here. DPD say, I am also here. More the column, won't there be more chaos? Because so many people are saying prediction should be 0, prediction should be 1, and the machine learning model will be confused. More the columns, more the people are talking. All the columns are saying, you have to listen to me, you have to listen to me, you have to listen to me. Won't the model be confused? Who do I listen to get my prediction? Right? And it is good to be wrong. My people, when I started machine learning, okay, and when I learned machine learning from my instructor used to also ask me questions the way I'm asking you. And I used to also say no, and then I used to say yes. It's okay. It's a fun part of the game. That's the beauty of learning together, right? The point is, the more the columns you have, the higher the chances of something called overfitting. Okay, I have not taught you what is overfitting, underfitting. But more the chances, more the overfitting. So tell me, does it not mean that by default, if a model, a machine learning model with 4 columns exists and a machine learning model of 100 columns exists, because the numbers of columns are higher, R square will always be closer to 1 because the number of columns are so many. So don't we want a true measure of R square? Even if the columns are 2000 tomorrow or 100 or 4, you give me the proper value of R square. Yes or no? You got what I'm trying to say? If the numbers of column increase for a linear regression model, higher the columns, R square will always be pointing to 1. But is the real value of R square 1? No, sir. It's because more the columns, more the representation. So don't we need to adjust our formula in such a way that even if the number of columns are higher, it will give us the right value of R square? That formula is called adjusted R square, because the R square formula that I taught you, is it adjusted? No, it is not adjusted. It is not fixed. This is the formula that is fixed. So what is the formula of adjusted R square? Is R square nothing but your sample R square that you normally calculate the way I calculated? Yes, absolutely correct. But you divide the equation by total sample size. Can you see I'm dividing this by total sample size n? The sample that I have taken for the consideration of R square, that sample. At the same time, can you see number of independent variable here? This is nothing but the number of features. If your data is working with 100 features, am I not dividing and subtracting it with n? So I am penalizing the model, saying that if you take more number of features, your division also will be larger. You got what I'm trying to say? If your column is 100, suppose if your feature set is 100, I will divide you by 100. So the number also will be that much smaller. But if your column is 10, I will only divide by 10. So be careful. Don't get overconfident and take too many columns. You got what I'm trying to say? That's the logic behind the R square formula. If the number of features are higher, R square is likely to be near 1. Of course, 100%. If the number of features that you have taken are very, very large, what happens in your R square? Because each individual column will start saying that you have to listen to me, you have to listen to me, you have to listen to me. What happens in that situation? What will happen in that situation? I mean, think about it. More the number of dimension, more the number of models complexity increase. What will happen with that? If the model's complexity increase, what happens to the model? Will it get confused? So closer to 1. That is your answer. It'll basically overfit itself. It gets so overconfident on the training data. On test, it basically performs nothing. Is everyone clear until here? This is the formula for adjusted R square, meaning you penalize it more. If you want to take more columns or features, I will divide you by that number of size, and you will be equally reduced in your R square. For more number of data or less number of probability of getting a good fit is high. See, let me answer this in this way. Sometimes when you do machine learning, listen to me, I'm asking you a simple question. Sometimes when you do machine learning, do you want more and more columns, more and more features? That is the requirement of my machine learning modeling, but are anyway trying to get R square closer to higher. How is it a problem? We never try to get the R square closer. And just focus on this part of the piece of code. Just be here, okay? I want to ask you guys a very simple question, okay? What data did we take for our prediction? What answer did we take for our prediction? Or what answers have we take? What data did we take week versus something, right? So what I'm going to do is import pandas as PD. Can I do this? Import numpy as NP. Can I do this? Import matplotlib.pyplot as PLT. Do I say these are the most basic kind of, I don't know, the most basic kind of approaches whenever we are writing any code? Okay, exactly. that representation of R square is not good because anyways, more the columns are adding and making the R square closer to 1. That is not a true reading. I'll give you guys a knowledge. Okay. Give me 1 second. So tell me, when you cook tea or when you make tea, you don't cook tea, you make tea. TEAT. For 4 people, the amount of sugar you add is 2 cup or maybe 2 spoons or 3 spoons. Agree, disagree? When you make a tea for 100 people, will the amount or the quantity of sugar that will go will be larger? This behavior is normal and is common in the human system, ecosystem, right? If you are making a tea for 100 people, of course, the sugar is larger. You make a tea for 4 people, the sugar quantity will be lesser. If you reverse this situation, what happens? Disaster. For people, you want to make 4 cups of tea, adding 100 cups of sugar. And for people, 100 cups of tea, you make 2 cups of sugar. Is it disaster? Okay. So according to the size and the quantity of the data, should you adjust the sugar size? Larger the feature set, do I need to penalize it, control it, maintain it, so that the R square value that I get is not a number closer to 1 by default? That is not the true number. That is not the true representation of the number. I hope you got what I'm trying to say. That R square is not the true representation. The actual R square should be adjusted because automatically when the number of features are larger, it becomes overconfident and says that R square is 1. But in reality, R square is 60, 0.60, 0.70. It shows 0.9. Not good. Penalize. The logic is clear. Why we do this? That's why we do this. Have I taken all the packages? Matplotlib, NumPy, Pandas, and all of that. Weeks underscore data. Tell me, how many cars do I get to sell in a week? 1 week, second week, third week, fourth week, and fifth week. I only took till fifth, right? If I'm not wrong, I only took till fifth week, correct? Right? Okay. Then the sales underscore data. Sales data is, what did we take? I don't even remember the code. What was the sales value? 24545. Okay. 2, 4, 5, 4, and 5. Is this my weeks data and my sales data that I have taken as per what we did in the coding? Very good. So tell me, listen to me carefully. df equals to pd.data frame. If I want to convert all of them in data frame, do I take it in a dictionary format like this? Like take a dictionary like this, a single dictionary? Can I say it like this? Weeks, colon. What do I pass? Weeks data. Bracket, sales. Now listen to me carefully. Everything will start making sense a little bit more to you, okay? In machine learning, whenever you do in the production, whenever you're writing code, how you cut your birthday, right? How you cut your birthday cake. Just like that in machine learning, you need to do 2 cuts, okay? 2 cuts, C-U-T-S. Sir, what are those cuts? I'll tell you. Imagine this is your data, okay? This is your column data, your Excel data, your, good looking, beautiful looking Excel data, okay? The first cut you need to do is separate target and feature separately. Suppose I have a column called feature 1, feature 2, feature 3, feature 4, and target. Where is the first cut you will draw? Okay. Where is the first cut you're going to do? You are going to separate your target and your feature separately. Am I making sense? Your first cut should be to separate your target and your feature separately. Usually in machine learning, target is taken as X and the feature or your actual feature, sorry, your feature is taken as X. Okay. Your feature is taken as a variable called X and your target is taken as Y. Did it become clear? Your features will be separate, your target will become separate. So tell me here, can I take something called x equals to df of, specifically df at weeks? Can I say all the values of the weeks will be converted to x? So if I print x, all the 1, 2, 3, 4, 5 value of the weeks are separated in x. Yes. And your y value will be, your value of y will be df of sales dot values. So what did you do? Did you take your x and y separately? Did you take your x value and your y value differently, your variable separately? So you have done that. The second cut you're going to make is separate something called as training versus testing. I'll explain the concept. You make a cut like this. Okay. This much data is training data and this much data is testing data. Okay. I'm going to explain this concept a little later to you. I'm going to keep this graph in the next. Did I first make the first cut as per what I had done? X and Y is separate. The first step that we do is calculate the mean of X and mean of Y, correct? In the mathematical example also, I calculated the mean of X separately, then mean of Y. Mean underscore X equals to NP dot mean of, what do I pass? X. Mean of Y is going to be NP dot mean of Y. Did I take the X separately and the Y separately? The mean of X and mean of Y? N is equal to length of X. Basically, I am taking another variable called N where I am understanding how many X parameters do I have, meaning how many independent feature sets number do we have. N will represent that. NUMER, numerator is equal to 0, denom is equal to 0. What have I done here? What have I done here? What is the concept here? Numer is equal to 0, denom is equal to 0. Have I taken something called as a counter? In Python programming, this is also called as a counter. This is counter. I have initialized the number to 0, correct or not? This is a counter that I have taken. Okay. In the mathematical terms of doing the R square calculation, sorry, in the calculation of y is equal to mx plus c calculation, numerator is nothing but x minus x bar into y minus y bar. Agree? X minus x bar into y minus y bar. X minus x bar into y minus y bar. Please tell me, for I in range of n, how many data points am I going through? All the values of x? Am I looping through all the values of x? 1, 2, 3, 4, whatever values of x is, I'm going to calculate its x, x bar, y, y bar. I'm going to calculate all of that. Okay. Can I say numer, NUMER, plus equal to, numerator plus equal to, keep on adding that number is x of I, which is the actual value of x minus mean of x. Is this x minus x bar? Is this code, as simply put, nothing but x minus x bar into y minus y bar? So y will be taken like how? Y of I into mean of y. Is this x minus x bar into y minus y bar? I am simply looping through the code. I am simply looping through the code. How many? First, I will take row number 1, then row number 2, then row number 3, then row number 4, then row number 5, then row number 6, then row number 7, and it goes and on and on and on. I'm sorry. What? Isn't it minus? What is minus? What did I do? Where did I make mistake? X minus X bar into, oh, sorry, Y minus Y bar. Yes, sorry. X minus X bar into Y minus Y bar. Correct. Okay. So X minus X bar, Y minus Y bar. Numerator is done. What do we need to solve for next? What do we need to solve for next? X minus X bar is done. Denom. Denominator plus equal to, what is going to be denominator? Look at the formula. Denominator was X minus X bar the whole square. X minus X bar the whole square. So how do you write X minus X bar? X minus X bar the whole square. Can I say this? This is x minus x bar the whole square. Okay. If I come outside the loop to calculate the value of m, do I need to divide numerator by denominator? Numerator divided by denominator should give me the value of m, correct? M should be equal to numerator divided by denominator. Agree or disagree? Okay, that's good. And what will be the value of C, my people? What will be the value of C? I have written the formula right here. Can you see? Y bar is equal to mx bar plus C. Y bar, sorry, give me 1 second. Y bar is equal to mx bar plus C. So can I say C is nothing but mx bar, sorry, mx bar plus C. So if I move y bar minus mx bar, can I say it like this? Can I say this is going to be y minus mx bar? So if I write it like this, mean of y minus m, whatever value of m I have calculated from top into mean of x. Can I say it like this? If I print f double quotes of m is this. And the value of c is this. Did I get the value of m and c? Now we make plots. So now I'm going to do some plotting. Why plotting? Because we just calculated y is equal to mx plus c. Yes or no? We have the value of m and c. We just need to put the value of x. So if I say max underscore x equals to, just try to understand the code I'm writing, okay? np dot max of x plus 1. Min of x. np.max, np.min of x. Because it is the min value, I'm going to take -1. Okay. Who knows what this np.linspace? Have you all used the method called linspace? Have you all heard of something called linspace? Comma max of x, right? You guys have heard about something called this, right? Mx plus c, correct. That would be 1, 2, 3, 4, 5, 6, 4 and 4, and then mx plus c, right? That should be fine. That's my equation, correct? From min to max, which is correct. Okay, fine. See, I'm very sure you must have studied something called linspace you guys did do something called numpy, right? You guys have studied something called numpy, correct? I'm assuming that numpy is done. Okay. Or maybe, I don't know. Let's take a little maroonish color like this. Yeah. Let's come to this part of the code and change this to hashtag this. Color is done. I can change the label also. X and Y in color. Okay. And you guys have studied matplotlib, correct? So what I'm doing here is I'm writing a label because this is going to be sort of like my regression line. Okay. Regression line that we have just calculated from that particular thing. Okay. Line style will be, I'm going to keep it actually dashed so that you guys understand dash dash. That's more than enough. I will take no alpha if you guys don't want it. Plot dot scatter. Okay. Inside the scatter plot, I want to plot the original values. So I'm going to take x comma y, the one that I had originally. Okay. So the color is equal to, let's take sky blue. Sky blue. And the label I want to add, because I want to add a legend, legend later on. Label is equal to the actual scatter point or the actual data point. You can call whatever you want. POINT, right? Actual data point. And actually, I can make them bigger or smaller. I think I can make them bigger. How do you make the points bigger? Actually, there is something called width. Yeah, I think I have to check it. So Plot dot plot is done. Plot dot scatter is done. I have taken two specific plots. Okay. So plot dot X label. So let me first take an X label. On the X label, I will say the number of weeks that have elapsed. Okay. Weeks. And plot dot Y label will be, the actual sales of the cars that have been done. So I will say sales, and plot dot title. I'm going to take the title of the plot to be, demo of linear regression or whatever it is. Linear regression demo. Okay, demo. And then we are going to do plot dot grid. Let's make it true because we want it to look good. And we will say plot dot legend, and the location will be equal to best, right? So the lock will be equal to best. Upper left, upper right, depends on how you do it, right? Okay. Let's not make it sky blue. Let's make it black. Yeah. Okay. Not even black. It's not looking good. How do I make it lighter yet darker? Oh, I think this is darker color. This is like a good looking dark color. So I'm gonna take this copy. I'm gonna come to this code. We're gonna go to hash and paste. Let's make the grid a little less uh, lighter. Alpha 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 equals to, let's make it 0.5. Now let's make it little 0.3. Let's also make it line style is equal to, let's make it dashed, right? Let's make it like this. Please tell me if you're, better. Looks good. Now let's make the alpha better, 0.4. Good. Okay. Do you see what has happened here? We have 4 data points, 1, 2, 3, 4, 5, 5 data points. The red color line is what is actually called as the fit line that we have observed. Yes or no? The red color line is the actual y is equal to mx plus c line, and the blue dots are the actual data points. You got what I'm trying to say? Let's make it a little bigger if you want. Please tell me if the code is correct. No. Is it capital S? I'm not sure. S is equal to 40. Oh, I think I'll get an error. Or small s equals to, let's make it 70. Yeah. Okay. Now listen to me carefully, okay? What have I done here and how am I basically printing these values, okay? See, predominantly, I want you to understand just one thing. Just one thing, okay? I have taken something called max of x is equal to np dot max plus 1 and minimum of x is np dot min minus 1, okay? The largest number of the value of x, is it 5? Plus 1 will be how much? And the most minimum number in x is what? 1. Minus 1 is 0. I want to make a plot. I want to make a plot where the x-axis will start at 0 and end at 6. Did you get it? Limitation on the x, the direction of x. Okay. Now what did we do? X equals to np dot linspace min x and max x. Do you know what does linspace method do in NumPy? Everybody? Do you know what linspace does? Everybody? You guys are clear, right? What linspace or this line space does? It's actually spacing. It's for spacing. You guys are aware. So I don't need to teach you this, correct? I don't need to teach this x equals to this, create equal spacing. Very good. I have taken something called y is equal to mx plus c. I plotted x comma y with a different color with a label and a line style. I plotted the scatter plot x and y, the actual data point, color, label. I did the x label, y label, title. I've put the grid in the background. Alpha is the intensity. How do you want the intensity to be darker or lighter? Line style is the style of the line. And then legend is basically regression line and data point. And I plotted this data. Yes or no? Are we visually clear on how this particular thing works? Are we visually clear with the concept of something called how does the whole thing work? It's good. Very, very good. You got what I'm trying to say? You don't know what is grid and legend. Okay, so you don't know what is grid and legend. Do you see the background grid? Okay, let me make it alpha 1. Alpha 1. Alpha equals to 1. Okay. Do you see the grid in the background image? Let me show it to you like this. How about now? Is there any grid in the background? No. Correct. But the minute you say plot.grid and pass inside the parameter called true, it will make the grid for you. If I run this answer, this red color line is what? The blue color points are what? We don't have that information. If I don't have that information, then the plot looks incomplete, right? I want to label it in the plot. So if you do plot.legend and print it, can you see the red color thing is called regression line and the blue color points is called data point. This difference is what we call as legend. How it figured out without giving figure size. Matplotlib has everything by default. If you don't give any figure size, it won't give you error. It will still run. I thought you guys knew this by now. Nobody takes figure size. Nobody in real practical applications takes figure size. Figure size is very illogical and also irrelevant because if you take more than 5 plots, subplots will take care of by itself. What max x and min x does is a very simple thing, right? When you plot any graph, you want to know how long do you want your x axis to go and where do you want to start your x from. You want your starting point for the x axis to start at some value. Now, it so happens that not every time the x and y graph will start at 0, 0 only. Sometimes a graph can also start like this, right? A graph can start -3, -2, -1, 0, 1, 2, 3. Sometimes graph can start like this also, right? Not necessary that every time they start from 0 to 0. So what I did is I took the X column, which is this weeks column, and I calculated what is 5 plus 1 because the maximum of weeks is 5 plus 1 will be 6.
Mhm.
So it will plot a graph where the ending point will end at 6 and the starting point will be minimum value, which is np.min. The most minimum value of x is 1. 1 minus 1 is 0. So it will start at 0, go all the way till 6. And then I can plot whatever y value I want. So to restrict the columns, sorry, the values on x, I did that. So now tell me, let me ask you guys one more question. Sir, if I do it like this, 100%, let's take -10 plus 10 and run this. What is your access value? What is your access value here? -15 to 15. You got what I'm trying to say, right? Plus 10 and -10 were added to your data. So your actual data point got shifted below. Can you see the points are now closer to each other? Let me copy paste this. Sorry, not copy paste and move this. And do you see the answer called 2.2734, 2.34, 2.42, 2.49? Okay. Y is equal to mx plus c. You will be like, there are so many values in this, right? There are so many values. Is that the question that you have? That y has so many values? Tell me, okay, print length of y. Okay. Length of y. Tell me, what is the length of y? 50. Okay. How many data points does y need if I calculate y is equal to mx plus c? In actual y predicted value, what answers am I supposed to get just for the prediction of y hat? Y is equal to mx plus c is supposed to give me 5. Okay. Tell me one thing, right? When you print y is equal to m into x plus c, okay? Did I break my actual x into multiple different data points here? This is not the actual x, the capital X. It is the small x. You didn't understand. Okay. Is this y is equal to m capital X, which is the actual data point plus c, or I had to take linspace because I had to plot the value for line also? You didn't get it. I had to print the value for each individual line, correct? So have I not taken x is equal to np.linspace? And it divides the whole data into 50 different points. And that's how I got a straight line. You got what I'm trying to say, or is there confusion? Did everybody get the concept or no? Okay. How many data points do we have in weeks? Okay, listen. How many data points do I have in week? 5. The name of the variable, is it capital X or small x? Is it capital X or small x? It is capital X, not small x. When I did y is equal to mx plus c, is it small x or capital X? When I wanted to plot the point, I wanted to show the line for the entire data point, right? For all the 0 to 6. For all the values of 0 to small value, I wanted to show. So tell me, if I did x equals to np.linspace, if I print x, how many values of x did I get? Equal portion. 0 to this is one portion. This to this is one portion. This to this is one portion. This to this is one portion. Haven't I divided my value also into multiple small points? Meaning your x-axis also got divided into so many smaller points, equal spaced value. Yes or no? Now, don't I need to do a line equation for all small points? So that is why I have not taken capital X, I have taken small x. That's why the line will go from the 0 all the way till 6. Longer line. Why are we doing it? If you don't do it, will you be able to plot a line? If I don't do it like this, will I be able to plot a graph like this? Like the line going all the way from here to here. That line, that red line going from left to the bottom, will it go? No. Line will start here, it will end here. Correct or not? The regression line will be so small, it won't be visible. That's why we are doing it. If you don't do that, you're pretty much done. You will not be able to plot. Then you will be having only y is equal to mx plus c. That's it. Like you will have 5 different answers. You will get this answer. Y predicted is equal to this, but you will not be able to plot it. This value, y hat. 2.8, 3.4, 4, 4.6, 5.2, and you're done. So what it did is it created some values and then connected the dots to create a line. Yes, that is what it is doing. If I take the values to be more and more, the line will always be visible. The line will not become shorter and longer. It will always be visible. The regression line will always be visible. That's why we did it. I hope you got the concept. In reality, it's only calculating 5. That's it. That's all it does. It's not a very complicated thing. So what if we have only 7 data points and not 50? Still, we will be able to plot. You can do it, Piyush. It's not a very complicated thing. If you want to plot only is equal to y mx plus c, write a loop, write x of I, and you'll be able to calculate it. Shouldn't be a problem. It's not going to be a problem at all for you to calculate it. What value of x's do I have? Do I have the value of x's like this? X is equal to, let me show you. What is the value of x do we have? Is it an array? So if I do x of 0, will it give me the value 1? So tell me, for I in range of, listen to me, for I in range of length of x, will this run the loop 5 times? If I print x of I, will this give me the value of each number 1, 2, 3, 4, 5? Now that you have 1, 2, 3, 4, 5, can I do this? Y is equal to m into x of I plus c. Can I do it like this? And close it and close it. And if I go ahead and print y, each time that the y happens, I print it. So 2.8, 3.4, 4, 4.6, and 5.2. Can you not take this in an array and plot it? You can, sir. Of course. It's a simple method. You know how to plot this, right? You guys know how to take 2 array values and plot them, right? You must have done that like multiple times. If you take another array, ar underscore new is equal to an empty array, and take this ar underscore new dot append. Okay, inside that append, what do? We append the value of y. If I run this, what is my ar underscore new value? Did we get the answer? Take this and plot it. Done. Now, my people, let's talk about the calculation of R square. How did we calculate R square? What did we do in R square? Sum of square total, sum of square residual, all of that stuff. We'll be talking about that. Okay. So as you guys already know, we calculated something called R square, right? To calculate R square, sum of square total, SS underscore TOT total. Okay. Is it going to be empty? It's going to be 0. Sum of square residual is going to be 0. Okay. I have taken 2 separate counters, sum of square total, sum of square residual. Listen to me. For I in the range of, how much do I need to run the model? How many times do I need to iterate? N times, because I've already taken the value of n on the top. Y underscore pred. For calculation of R square, I want the value of Y predicted values. Yes or no? For the Y predicted values, I want the values of Y pred. So can I say y pred is mx? X is nothing but x of I and plus c. Can I say it like this? So sum of square total plus equal to, based on the formula that we wrote, y minus y bar the whole square. Listen to this. Y minus y bar the whole square. The whole equation is reversed. That's why we do 1 minus. I'll show you. Y minus y bar the whole square. So can I say the equation will be written like this? Y of I minus mean y the whole square. Y minus y bar the whole square. This is my sum of square total. My sum of square residuals value plus equal to y minus y pred the whole square. Opposite. Y minus y pred the whole square. So y of each individual point, actually this is capital Y, okay, because we are taking from the actual value. Y minus y of I minus y pred the whole square. I have taken the value of sum of square totals and sum of square residuals. Based on this, my R square answer that I got is 1 minus sum of squared residuals, right? So sum of squared residuals divided by sum of squared total. If I run this and print, go ahead and print F double quotes R square is going to be R square. If I run the answer, what answer did we get? What answer did we get? 0.6. What answer did we get here? The only difference in this formula and that formula is sum of square total and residuals are opposite. Agree? They are numerator is denominator, denominator is numerator. So if you do 1 minus the reverse case, is it the same thing? In mathematics, when you want to reverse A by B with B by A, you just take 1 minus of sum of square total by sum of square residual, and your answer is pretty much the same. I hope you got what I'm trying to say, everybody. So tell me, did we use any library in this? But we got the value of R square and y is equal to mx plus c. Can we validate? Do you understand what is validate? If I would have used a machine learning library like sklearn, scipy, what answers are they saying and what answers do we get? Can we validate it? From sklearn dot linear model, I'm importing something from sklearn dot linear model. I will import something called linear regression. Can you see I'm importing something called linear regression? I'm importing a model called linear regression. I've imported x equals to, now remember, the problem is when you use a library like linear regression, sklearn, stuff like that, it needs the data to be in two-dimensional format. So your x value should be reshaped. I'm going to reshape the value to -1 or n comma 1. So if can I take it like this, n comma 1? What does this do? Do you guys know what reshape does? N comma 1. The value that we had, was it not a single array like this? The x value was a single array. If I print x here, is it not a single array, one-dimensional array, one bracket open, one bracket close? But in sklearn, you cannot run like that. You need to have the data, even if it's 1D array, it should be in what format? It should always be in what format? 2D format. So this reshaping, I converted the entire form into a 2D array. Are we clear? We converted the whole thing into a 2D format. Now that the whole thing is converted into 2D format, let's take this as a small x, not a capital X, because there will be a lot of confusion. So let's run. Okay, x value should be equal to this. The problem is what you need to do. You need to call the library. Regression is equal to linear regression. Close the bracket. Regression is equal to regression dot fit. And inside the fit, you will pass something called the actual value of x and the actual value of y. Did I make a mistake? I did make a mistake. I think there is a shape. Oh, I took it as a small x, correct? I did take it as a small x. Yeah. What did I do here? This 2 lines of code has run the model. The model has run, meaning linear regression has occurred. You don't need to do anything else now. Your value of y pred, y underscore pred value, the predicted value that I want to calculate is going to be m into x plus C. If I do, you know what, let's take it in X format only because I'm taking it separately. So there is no confusion here. Okay. Mx plus C. My people, if I calculate the Y pred value like this, Mx plus C, right? And if I run that value directly, suppose if I want to just run the value of Y pred straight up, because I'm using the package directly, if I have reshaped the value, or maybe, maybe I'll do it like this. Until here, is everyone clear? Let me run this once again. Until here, is everyone clear? I have run the linear regression part. This part is called linear regression. I have just used the method. Why do we need to reshape Y? We never reshaped Y. We only reshaped X. We only reshaped X. We never reshaped Y. Where in this code do you see reshape Y? Where in this piece of code have we reshaped Y? Why not? Okay. When we run machine learning or when we run machine learning code, Y is only for prediction, right? But the actual mathematics is happening with the feature numbers, right? Y is not even getting involved there. Does that make sense? Your X value, which is the feature value, your X is being crunched. Your mathematics is only operating on X. Y is just a number that can be compared. Suppose if the Y value was 4, Y pred is 3, the maximum you do is Y minus Y pred. Agree, disagree? The entire operation is running Y is equal to Mx plus C. The X is being multiplied with M and then added with C. All this operation happens on the X value, correct? So the reshape has to happen only on X, never on Y. All of you got the question that features are the one that goes through a lot of mathematics. Target just sits. It has no operation. The maximum it will do is Y minus Y pred. Done. Everybody got what I'm trying to say? What did I do here? I took a value, I reshaped X, and I'm running linear regression. Basically, this value here is running linear regression. Agree, disagree? This particular value is running your linear regression. That's it. You've run. Now, if I say Y pred value, whatever is your Y pred value that you want to score or you want to calculate. So if I want to calculate the value of, say, R square, you want to calculate the value of R square. If I say R square is equal to, just R square is equal to reg, because I have taken everything in the small reg. Reg dot score, SCORE, pass X comma Y directly. And if I print R square like this, what answer did we get? What answer did we get? 0.59999. Is it 0.6? What answer did we get for R square? We got an error of 0 point or 10 to the power of minus 12 with least significant digit of 10 to the power of minus 12. Did you understand? I ran a model, a linear regression model. By the way, this is not modeling. Modeling, I will teach you how to do that. But when I ran the algorithm, the actual library versus our code, we got the same exact answer. You got the concept, my people, on how we wrote linear regression from scratch, how we implemented it from library, the numbers match. If R square is matching, M and C also is the same answer. The point and the plot is also the same answer. Everything that we've done is calculated. Did we get the concept clear? Now, in the formula of R square, did I not take the value here, the formula? Y hat minus Y pred the whole square. This formula, I have taught you this formula. This formula is already given. All I did, sum of squared total was Y minus Y bar, the whole square, and Y minus Y pred the whole square. We had taken opposite, but in actual R square formula, we take 1 minus of this value. When we take it like this, whatever formula we get on, whatever answer we got then, we got the same answer here. Validate part is confusing. It will be confusing. Have you ever used a method called linear regression or linear model ever? No. This is not for your understanding. This is only to show you that the answers are same. Even if you don't understand the code, it's okay. This is to show you the difference. Linear regression formula, library, and our way of written, we got the same answer. Is going to be a very simple thing, right? I'm going to be importing something called import pandas as PD. Now, I'm going to ask you all a very simple question. This is not the first or a very new library for you, right? I'm very sure you must have implemented this library and you have learned this library, so I don't have to teach you. Okay. Hiding internal implementation and use of existing libraries as and when needed instead of rewriting the code. Yes, absolutely correct. The abstraction in object-oriented programming is different from the abstraction that I am talking about, but you got the logic correct, right? So encapsulation, polymorphism, injection of control, dependency injection, you know, adaptee, adapter. These are all object-oriented principles, SRP, single responsibility principles. These are all object-oriented principles. They are very technical in nature. What I'm talking about is the basic concept of abstraction, but I'm very glad that you got it. Knowing object-oriented skills, programming skills is very important, right? So now what we've done, we've imported pandas as PD. I want to load a data, right? So I'm gonna keep this thing as import all other OTHER libraries here. Okay, import all other libraries here. Here, I'm gonna load the data set. I'm gonna load the data set. Okay, let's load the data set. Data is equal to PD dot. Now I already have an API or a method which is given to me, using which I can load the data set, right? So pd dot read CSV. And my people, I'm going to give you guys certain tricks. I'm not sure if you know them or not, but I'm going to do it. See, in pandas, you have a trick of loading the file directly, right? So if I want to load it directly, I have this. See, now my data is loaded. Okay. So I have loaded pandas and I have loaded the data set. Now, let me tell you the trick I use to load a certain file faster. Okay. Every computer has a structure called folder. Yes or no? You create your own folder. You can create your own folder. Inside that folder, listen to me carefully. Inside that folder, how many files are there? To find that out, you can use a trick called dot and forward slash. A dot and a forward slash. When you use dot and a forward slash and press on tab, you can see all the files. So you see this headbrain.csv. Now I have loaded this file. So basically, a method called dot read CSV reads the file called CSV. Now, what is CSV? It's comma separated value. Now let me tell you two different things. You guys are currently learning machine learning on a tool called Jupyter Notebook. Like Jupyter Notebook, there is something called Google Colab. Like Google Colab, there is another tool called Visual Studio Code. These are platforms on which you can write the program. This CSV is the format of the file on which you work. Sometimes you work with Excel format. So the extension will be .xlxs. If you work on something called Apache Parquet, so you will have Apache Parquet, Apache Parquet, right? If you work on Hadoop distributed file systems, then you will have a different kind of data set that's given to you. If you work on Carrot file, it'll be different for you. Remember, in machine learning, you can use as many different kind of structures as you want. Depends on what is the file structure that you have. Okay. It is so if the same folder available to no. Dot slash only gets you the file from the same folder on which your file ml underscore ff is written. Your folder needs to be same. If the folder is not same, it's not going to go beyond that to get it for you. Okay. What is the difference between Jupyter Colab and Visual Studio? See, Visual Studio is something that you will appreciate a lot. Like if I show you a Visual Studio code, I'm not sure if I have it with me. I mean, not here, Visual Studio code. Okay, I'm going to show you the difference between Colab and Visual Studio Code. Actually, you should really know the difference between Visual Studio Code and this. So you see, right now, this is inferential stats that I was teaching a while ago. This is extension. Give me 1 second. Let me go ahead, and I think I had a folder somewhere. I'm gonna open it up for you guys. Give me 1 second. Desktop, and I have A to Z. I think I was teaching. Yeah. Let me see if this is the, yeah. So this is like a small data structures code that I was teaching to a recent batch right now. So see, this is written in an IPYNB file. This is how Visual Studio is going to look like for you. So you see, it has a certain theme. So I'm just going to expand it a little bit, right? So I'm going to, yeah, show it to you. So what happens is basically, if you run a portion of this, so for example, how do you find the second largest and the second smallest thing from an array? So you have a certain way of doing this. So what happens in Visual Studio Code is Visual Studio Code can help you write any kind of program with a proper and a beautiful file structure. So you can maintain and work on the database together, files together, multiple different stuff like Docker, Kubernetes. If you want to build a Docker container for your, code, if you want to do a blue-green deployment, so you can do all of that in one place. Jupyter Notebook is more like for beginners. If you're a beginner, you're just starting with your machine learning journey or starting with your programming journey, people usually prefer Jupyter Notebook. But Jupyter Notebooks are not predominantly used for deployment, meaning you don't take a Jupyter Notebook file and you're going to be use it for deployment. Some people do that using Amazon Web Services and Kubernetes services, but usually it's not preferred because you have to do load testing, stress testing, pen testing. It's like regression testing. That's like crazy amount of stuff you have to do. Okay. For VS Code, we need to create environment for Jupyter, or do we? You can use it directly. It's directly. All you need to do is just download Darwin. So VS Code Darwin. If you just just download Darwin, you should be able to work on it, or just write Visual Studio Code, right? Like VS Code, depending on your computer, MacBook, or whatever it is, download. That's it. Just download, install the kernel, you're done. Okay. Colab is just like that. Colab is exactly like Jupyter Notebook, but it works on cloud. So uh, if I go to Colab for you guys and show you just one example, I have a pro version. So I'm going to show it to you differently. So see, this is the code of large language model like GPT. If you want to make your own GPT, this is a code for that. I'm using something called Microsoft 5 3.5. So see, for example, if I want to chat with my model, so if I ask a question like, like, hey, can I extract some image information from the from a given image or something like that? So see, I use something called as Google Colab Pro. The difference in Pro is I get an opportunity of connecting with something called A100. A100 is a very expensive GPU. So you will not have this option. I have this option. You will only have CPU or GPU or TPU. In Google Colab, what happens? You are able to load your data in a separate file called file structure to the left. So you have files here, so you can load your data there. That's the only difference. It's just like Jupyter Notebook, but the way it is done is slightly different. Okay. So Jupyter Notebook is same, Google Colab is same, and all of that is same. It's just that you can use a lot of, you can do a lot of fancy stuff with Google Colab. GPU for image processing, GPU for large language models for inferencing. When you write a query to a GPT model, you need the answer to be as fast as possible. For that, we use GPU. Okay. So now coming back to the point, right? I have loaded the data set. I want to test my data set. How do I do that? Data.head of 5. And if I run this, what data do I have right in front of you, my people? Let's look at it. I have 4 columns. Those 4 columns are, I have gender, I have age, I have head size, and the size of the brain in weight. Okay. So this data set that is available right in front of you, you guys are able to see the, okay, how about now? Is this more clear? Much better? I've zoomed in for a better clarity. Okay, good. So the data set that I have right in front of you is a very simple data set. It has 4 different columns: gender, age, head size and brain weight. Basically, I want to predict using linear regression that does increase in the size of the head increase the weight of the brain? Basically, if the size of the head is larger, does it mean that there exists a relationship between the weight of the brain? Meaning, larger the head, larger the brain, smaller the head, smaller the brain. To us, it looks like, I think it's common sense, but I don't know. There must exist a relationship, and we will calculate that using linear regression. So, in order for me to implement it using linear regression, I need to identify one thing, understand one thing. Okay. And I want to teach you this very, very clearly. Okay. So see, I have taken this example right in front of you. Gender, age, rank, whatever, whatever, X, Y, Z, right? I'm going to come over here and I'm going to paste it in front of you. Okay. So give me 1 second. Cut. And I think, why don't I paste it in the view sheet? Okay. Are you guys able to see this original data set right in front of you? Okay. This data set is what I would like to call the OG, the original data set. Okay. Now I will tell you how important is data scientist's job. My people, look at the data and observe carefully. How many variables or columns are categorical variables and how many variables are continuous variables? How many variables are continuous variables and how many are categorical? First of all, let me ask you all one question. See, my people, in statistics, you guys must have learned something called continuous variable, categorical variable, ordinal variable, nominal variable. I'm going to revise that concept to you. Okay. See, whenever a number is continuous in nature, for example, temperature, can temperature be 47 degree, 37.19 degree, 97.26 degree, meaning it can belong to any range of negative infinity to positive infinity. A number that exists continuously and can be any number between negative infinity to positive infinity. This kind of variable is called continuous variable. What do we call this? What kind of variable do we call this? This variable is called continuous variable. Let me show you an example. Between age, gender, head size, and brain weight, which number is any number that is continuously going on? Isn't head size and brain weight continuous? I'm asking everybody, whoever I taught you, both head size and brain weight are numbers between 4512, 3738, 4261, 3777, 4177, 1530, and all of that, and all of that, and all of that. Listen to me carefully. Data of just gender. If I just take gender, dot value counts. Okay. Dot value counts and run this. The gender column has only two kind of people. If you are one, it means you are a male. If you are two, means you are a female. So tell me, in the column of gender and age, let me also take age very, very quickly. Paste, remove gender and say age. And this. Do I also have the same category like 2 and 1? It's like category, either this or that. Is it continuous by any chance? Everybody, whoever did not know the difference between categorical variables and continuous variables. So, head size and brain weight are continuous variables. You will find numbers which can belong from negative infinity to positive infinity. But when you go to columns like gender and age, do we have infinite amount of genders available in this planet? No. So this value becomes categorical variable. What variable will it become? Categorical variable. So now that you have the clarity, this variable and this variable, gender and age, is it categorical? And head size and brain weight, is it continuous variable? And the answer and the distinction is clear. Am I making sense to everybody? What is the difference between a continuous variable and a categorical variable? Did you guys get the clear your differences clear, everybody? In the most simplistic sense, I hope everyone is clear. Is there yet anybody again who has confusion? I don't believe there should be, but I am asking. No. Okay. The the answer is clear. Okay. For implementation of linear regression, we have no use of gender and we have no use of age rank or range. We don't need them. It's not needed for my analysis. They are not helpful in any perspective. So I need to remove them from my original data. Now, here is what I want you to know and listen to me carefully. Sir, does that mean whenever I implement linear regression, I should never take categorical variables? I should only take continuous variable? The answer is no. If you want to implement linear regression, listen to me carefully. I'm telling you, this is very important. If you want to implement linear regression, your target variable should be continuous in nature. What variable it should be? Your target variable, whatever you're trying to predict, should be continuous. Your features could be a combination of continuous categorical. That's okay. Did that make sense? Whenever you want to implement linear regression, the rule is, the law is, the target variable that you will take will follow what variable, should be of what kind? It should be a continuous variable. You cannot take a target variable where the data is categorical. This is not allowed for linear regression. Very good question. See, this is what I want to know. But gender and age might also have an impact on the head size and weight. It does. But the problem is, in machine learning, can I say that your gender, age, and head size is going to be my feature data set and the brain is my target? Can I split my data set like this? Can I do this? Okay. Meaning, using head size, I can predict the brain weight. Okay. Given the size of the head, I can predict the size of the brain. Okay. In machine learning, you can do something called feature engineering. What do you mean by feature engineering? Is gender important for my calculation of brain weight? Is age important for the calculation of brain weight, or head size is important for the calculation of brain weight? And then the machine learning will only tell you, don't give me gender, don't give me age. They are not adding any value. Just give me head size. And when I did that and when I ran that, it says only head size has more correlation with the prediction of brain weight versus gender. Now, why am I not showing you feature engineering? Because that code is very, very large and you haven't yet come to the concept of feature engineering. So now did everybody understand why am I asking you to drop gender and age? Because these are not adding any value to the final prediction. Hence, we are going to be dropping these columns. But I will be teaching you how to do this calculation all by yourself. How to take a feature set of multiple different columns and identify which columns are important and which are not. In specifically linear regression, what variable cannot exist for target? Tell me. If you are implementing something called linear regression, your target variable should be not of this type. What is that? Not categorical. What it should be? What it should be? It should be continuous. Number one. So tell me, what do we do? What do we do here? First of all, I took something called gender. I took something called age. I got something called head size. I will be only using the data set from the original data set. What I'll do, I will take my original data set, okay, which is this, and I am going to, I'm gonna duplicate, okay, come to the bottom. And what I'm gonna do is I am going to remove these two columns, age and gender. And now I will be left with this two columns. So originally, what did I do? I had this data, but what did I do in between? I dropped dropped, dropped some columns, and I got the answer called, I got the data set as head size and brain weight. Agree, disagree? This is my original data. Now, this was my original data, but this is my data now because I no longer have needs of these two columns. Taught you the concept of something called as in machine learning. Okay. Just listen to me carefully and everything will make sense. Just like how we humans need to be shown some things for us to understand, machine learning also requires training. When I say training, it needs to go through something multiple times for it to get the idea. So tell me, my question is very simple to you. If I teach you 4 plus 5 is equal to, that's correct. 3 plus 2 is, reinforcement is different, Kalpesh, right? Reinforcement will be a different thing. But yeah, reinforcement also is like you have to train the model and get the idea. It's absolutely correct, right? So it's also going to be, it's also going to be same. You will get the concept. Okay. So imagine you have been taught how to do addition. 4 plus 5 equals to 9, 3 plus 2 equals to 5, 1 plus 2 equals to 3, and 2 plus 2 equals to 4. I taught you this. I taught you mathematics, okay, addition, where 4 plus 5 is 9, 3 plus 2 is 5, 1 plus 2 is 3, and 2 plus 2 is 4. I taught you this. If I now want to test, have you learned mathematics or not? Or have you learned how to do addition or not? What two numbers will I take? You didn't understand. Let me explain. I taught you how to add two numbers: 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. I taught you how to add using these numbers. Okay, good. If I want to test your mathematics skills, if I want to test your mathematics skills, should the numbers be different from what I taught you? Because if I give you the same number 4 plus 5, 3 plus 2, 1 plus 2, you can also cheat. You can also cheat, right? You can also memorize. My question was very simple. I said that when I taught you mathematics, I taught you using four numbers: 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. If I give you a number called 2 plus 2, wouldn't that be cheating? Because you can always memorize what was 2 plus 2, 4, and write it down here, but you did not really understood math, correct? You can cheat like this. So what if I, for testing, give a number like this: 3 plus 6 equals to whatever this answer is, right? I think it'll be 9. Yeah. You understood what I'm trying to say? And then if you're able to answer 9, then I know you have learned math, correct or not? Agree or disagree? Machine learning works exactly like this. I'll tell you why. Imagine you have an entire data set of all these numbers: 4 plus 5 equals to 9, right? 3 plus 2 is 5, 1 plus 2 equals to 3, 2 plus 2 equals to 4, and 3 plus 6 equal to 9. This is my entire data set. Okay. This is my entire data set. To train my machine learning how to do addition, what will I do? I will divide my data set like this. All this from the top will be used for training my machine learning model, but I will keep this number separate. Why will I keep this number separate? Because I want to test my model also. Hey, model, did you learn mathematics? The model will say, yes, sir, I learned mathematics. Okay, let me give you a question. But the question I'm going to give you, you have never seen it in the training. This question is unique, one of a kind. You have not seen it. But because you say you have learned everything from the training, you should be able to solve the problem. Is this logical? Is this a logical approach to test whether something who says that I have learned, to test whether this person has already learned or not, actually learned or not? If I want to test your mathematics skills, if I want to test your mathematics skills, should the numbers be different from what I taught you? Because if I give you the same number 4 plus 5, 3 plus 2, 1 plus 2, you can also cheat. You can also cheat, right? You can also memorize. My question was very simple. I said that when I taught you mathematics, I taught you using four numbers: 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. If I give you a number called 2 plus 2, wouldn't that be cheating? Because you can always memorize what was 2 plus 2, 4, and write it down here, but you did not really understood math, correct? You can cheat like this. So what if I, for testing, give a number like this: 3 plus 6 equals to whatever this answer is, right? I think it'll be 9. Yeah. You understood what I'm trying to say? And then if you're able to answer 9, then I know you have learned math. Correct or not? Agree or disagree? Machine learning works exactly like this. I'll tell you why. Imagine you have an entire data set of all these numbers. 4 plus 5 equals to 9, right? 3 plus 2 is 5. 1 plus 2 equals to 3. 2 plus 2 equals to 4. And 3 plus 6 equal to 9. This is my entire data set. Okay? This is my entire data set. To train my machine learning how to do addition, what will I do? I will divide my data set like this. All this from the top will be used for training my machine learning model, but I will keep this number separate. Why will I keep this number separate? Because I want to test my model also. Hey, model, did you learn mathematics? The model will say, yes, sir, I learned mathematics. Okay, let me give you a question. But the question I'm going to give you, you have never seen it in the training. This question is unique, one of a kind. You have not seen it. But because you say you have learned everything from the training, you should be able to solve the problem. Is this logical? Is this a logical approach to test whether something who says that I have learned, to test whether this person has already learned or not, actually learned or not? Okay. Do we need to clean data by removing any duplicates? We don't want to do that yet. The point I'm saying is, you will take your entire data set and divide the data set into two different portions. One data set is going to be called as training data set, and the other data set is called as the testing data set. Is this concept clear to everybody? Now listen to me. From the original data set of 100% data set, can you control how much percentage I want to use for training and how many percentage I want to use for testing? I can control that ratio also, meaning from 100% of the data set, can I use 80% of the data for training and 20% for testing? Should you have this control? Yes or no? Very good. Very good. Now listen to me carefully. Everything will make sense. This is my original data set, correct? Head size, brain weight, and all of that stuff. Yes or no? You should always do how many cuts in a data set? How many cuts will you do in the data set? Two cuts. The first cut will separate the feature from the target. So can I say that head size is the feature X and brain weights is the feature or target Y? Sorry, feature X and target Y. Can I say this? So the first cut I'm going to do is where the first cut I'm going to do is on my original data set, which is this data set. So how do we cut it? Duplicate it. Give me 1 second, my people. You know, I am not very fast. Give me 1 second. So what I'm going to do is I'm going to make a cut. How do I make a cut? Actually, let's copy and let's make a copy of it somewhere here safer later on. Okay. So what will I do here? I will make a cut here. Basically, this is going to be my feature. I'm going to say, okay, my feature set is separate. And now I am taking another cut, which is going to be called as crop, which is going to be my target variable separately. So what did I do? I separated my feature and I separated my target. I did this. I separated them together. The entire feature set has the name of the variable as x equal to. So this is x equal to this, and this is y equal to this. Agree, disagree? This is called as the first cut, separating the feature from target. The second cut you want, the second cut you need to do is in the X and in the Y. You know why? Because between this data, you need to decide how much percent you want to take for training and how many percentage you want to take for testing. So can I do this? Listen to me. Okay, so let me explain. First of all, the data set that we have loaded has what? How many data do we have in it? 234. Okay. This is only 5. For example, it has about 200 data set. So tell me, the first cut I made was this cut, separating the X and the Y. And the second cut I made was separating this. You know why did I do the separate cut? Because this entire data set is going to be used for training, and this entire data set will be used for testing. Did you understand what I did? I first separated the X and Y, and then I separated the X separately and Y separately, and I call them training and testing. Okay. For example, I have taken about 80% for training and 20% for testing. Agree, disagree? My people, this variable here, this variable, does it belong to X or does it belong to Y? Does this belong to X or does this belong to Y? This belongs to X. Underscore. Does this belong to training or does it belong to testing? So this variable is going to be passed in machine learning model as which variable? X train. This part of the data 4512, 3718 and 426 will be going to the machine learning model as X train. Now tell me, is this Y or X? Is this Y or X? Y. Y. Underscore. Is it training or testing? Training. So this will become my Y train. What is this? This is X. Is this training or testing? This is testing. So this is X test. What is this? This is Y. This is Y test. Did you understand? What did you do? You divided your data into four separate parts. X train, X test, Y train, Y test. Is everybody clear? We will be doing this in the example. But is the concept clear? Why do we do this? Is everybody following with me? You need to do this. You cannot escape this in your life of deep learning, generative AI, machine learning, statistics. You have to do this. So did you just divide your data set into four parts? Training, X training value is different, Y training value is different. X test value is different, Y test value is different. Agree? Once you divide all this data like this, how do you know your model has performed good or not? So I am asking you a simple question. This part of the data will be used for training. Agree, disagree? This training part of the data, both X and Y will be used for the training. Agree, disagree? The one that I have highlighted, both X and Y will be used for training. Whatever model has learned, machine learning model has learned, should I not create another folder or another column called Y underscore predicted column? Meaning, using the training example, if I give it the test example 37774177, it will predict some number like 1200, 1500. This is the actual value 1282 and 1590. This is the actual value and this is the predicted value, yes or no? And comparing the difference between these two columns, I will be able to say that, oh, okay, I am off by 2%, 3%. This is your entire machine learning. Is this concept clear to everybody? If the concept is clear, remember one thing. I am coming over to my data set right now. Is this my original data set with which I'm working on? This data set called data.head of say 10. Uh, this is the data that I have. My people, your machine learning model has done a good job or bad job. How do we know this? How do we know if the machine learning model has done a good job or bad job? By seeing the results, correct? But to see the result, you need to be able to compare it with something, right? Let me give you guys an example. When we were young, our parents used to tell us how good the neighbor's son is because neighbor's son got 90% and you got 80%. Example, I'm giving you an example. They had a comparison to do it with, right? Like you had somebody to compare it against. If you have nobody to compare against, can you do comparison? And by the way, I am Sharma. So, you know, Sharma ji ka ladka. So you get the concept. You have something to compare it against. So tell me, in the entire data set, how many data set did we take for testing? How many data set are we taken or have we taken for testing? 2 points. 80% is training, 20% is testing. Agree? 80% of my data will go into learning the module, meaning for training the machine learning model. For training the machine learning model. The machine learning model will learn from the training data. But now I want to test my module. I want to test my module. Okay. I want to test my answer. To test my answer, don't I need to give it the value of X for it to give me the prediction of Y? If I give it the value of X, it will give it, the machine learning model will give me some prediction. Oh, I think it will be this much. Correct or not? If I give the value of X test, it will give me some Y value, no? That Y value is called Y predicted value because this prediction is actually from the machine learning model. But the prediction is 1200 grams, 1500 grams. This is the prediction of the model. But don't we have the real value, the actual value that the model, the actual value in the data set, which is the Y test value? So won't you compare Y test with Y pred? You are comparing the Y test value with the Y pred value to compare and see. Oh, okay. My algorithm is off by 80 points in this data point and 30 points in this data point. This will let us know how the algorithm is performing. Did you get it now? How you got Y test value? It's good, dear. Y test value comes from the original data, my dear. This is my original data set. I split the data into 4 different parts. So can you see what I did? The Y test value came from this part. I took the value of Y, I took the value of X, I split Y into 4 parts. Part 1, part 2, part 3, part 4. The fourth part is the Y test value. We need Y. Why do we need Y predicted value is, for example, Anaga, you work in a very big bank. Example, bank, PDFC bank. You want to build an algorithm by yourself there so that any customer can come to your bank's website and can ask and add the details like what is that person's age, what is that person's salary, what is that person's CIBIL, and you will give the prediction. Your machine learning model will give the prediction that, hey, come over to the bank, we'll give you up to 5 lakh rupee loan. Example. To build this model, you must have used 10,000 data points to train the model. Model needs to do prediction for millions of customers for the future use of also from the same data set, the model, how well did it learn? How good of a job did it perform? To test that also, you need to hide some questions from the model. That data set is called testing data. Because we already know in real life, in actual life, for somebody whose brain size or head size is 3,700 centimeter square, the actual answer that we got using the using the calculation, actual answer was 1282. But because our model has made prediction, our model will make prediction, the model's prediction is this and the actual answer is this. So can we also not compare and see how good our model has performed on the data set itself? My question is, we don't have actual Y test data in real time. We always have Y test value. I think you guys are slightly off by some points. Let me explain. Let me get the clarity. When you're training your machine learning model on 10,000 data points, you can only test on those data, correct? Okay, let me explain. Suppose you have 10,000 data set. Your data size is 10,000. How much is it? Ignore everything. I want you to answer my question. I have 10,000 data points, Baba. कितने data points है मेरे पास? 10,000. What is 80% of 10,000? What is 80% of 10,000? Is it 8,000? And what is 20% of 10,000? 2,000? Now tell me, is my model good or bad? I can only test on the 2,000 data points and validate, correct? Yes or no? If I make future predictions, my future predictions, I don't care if I have the Y test value for that or not. No. I am testing for the given 10,000 data point. How did it perform on the two? That's it. My accuracy My model's performance will be judged only on the 2000. On the 2000, if it did a good job, I will use it for feature prediction because I know it's going to perform well. Did you understand why do we take test data? Test data is only to test. If it performs good in test, the point is it will perform good everywhere else also. You got it, everybody? If the model performed good on the 2000 testing data, meaning while I tested from the 2000, it answered 93% correct. So isn't the chances if I use it for future 93% it will do good? That's the point. So is it the test data the basis of Vipred? Yes, of course. If you give it the X test value, it will perform Y test. That's it. If prediction is not accurate, do we not give it more data to train? Yes, if that's exactly the point. If the training, if the testing is not good, we try to feed more data or we change the algorithm. You got it? If the answer that you want is not arriving well, then you either change the algorithm or add more data. Are we clear now? This graph is clear to everybody. Have any confusions? You please let me know now. Is it clear? Okay, now listen to me carefully. This is my data.head, how we arrived at Ypred. Yeah, I'll show you how Ypred is calculated. I will show you how Ypred is actually calculated. I'll show you how Ypred is calculated. Is that cool? In the practical part, so that your knowledge will be clear. Is this my data that I want to run machine learning on? Okay. I want to take a variable called x equals to data of which variable do I want my x to be in? I want the head size to be my x variable. Agree, disagree? I have already taught you this. I want my x to be the head. I want my y variable to be what? Or let me take it one point at a time. Values, okay? Dot values. If I run this and if I print x, have I taken x separately? All the values 4512, 3738, 3261, whatever the all the values of x is now separate. Now it is in the format of an array, a single array. It is become an array. Agree? Okay. What do I do next? I take another variable called y. Okay. I take another variable called y. Which portion of the y do I need to pass? Do I need to pass data of something called as, what do I specifically pass inside the y? I pass brain weights. I copy this and I paste it here. Dot values. So what kind of answer did I get? I got all the values of y as an array. Agree or disagree? So have I separated the x and the y now? Have I separated all the values of x and y now? I did. Now, to implement linear regression, I need to import some libraries. These libraries are already given to us from sklearn dot linear model. Using sklearn.linear model API, I'm importing something called linear regression. Did I import linear regression also? This function will help me run linear regression. I don't care how it is written. I just need to call it. Agree, disagree? Yes or no? From sklearn.model selection, import train test split. Have I done this? From sklearn.model selection, I'm importing something called train test split. From sklearn.metrics, import mean square error. Okay. Import mean squared error. And I'm also going to import R square error. All right. R2 score. So tell me, what did I do? Did I import the libraries? I'm not even using them. I have just called them. I have just called them. I am making them sit on the chair. I have not asked them to do anything. Agree, disagree? So far, I have only called them. I have not done anything with them. Okay. Because I have taken the x value separately and I have taken the y value separately, the x value currently is in what dimension? Is it in one-dimensional data or two-dimensional data? One. That for sklearn, your data should be what dimensional data? Two. So can I say x equals to x dot reshape? Inside the reshape, if I pass this comma this, and if I print x again, did it become 2D? If I print x dot ndim, The answer is 2. The number of dimensions have become 2. From one dimension, I converted that into 2 dimension. Remember, you don't need to do this with Y, only X, because X is the data that is being crunched by the model. Y is only for comparison. Only X needs to go through this process. Are we clear? Yes or no? Until here, is everybody clear? Oh, you don't know how reshape works? Okay. Have you ever done something called reshaping in NumPy? Have you ever performed something called reshape in NumPy? Okay. Okay. Sure. Okay. Okay. Listen. Array is equal to, listen to me. Listen to me carefully. Array is equal to np.array and pass any number inside it. 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever it is. 1, 2, 3, 4, 5, 6. There is a name of a method called array.reshape. So if you change that like okay. Did you understand this is how you declare an array in NumPy? This is how a NumPy is declared. Array is equal to np.array 1, 2, 3, 4, 5. This is an array. Okay. What is the dimension of the array? Is it a 1D array or a 2D array? Is it a 1D array or a 2D array? Okay. The shape of the array is 1D. Agree? If I want to reshape this, reshape bit array is equal to reshape RESHAPED underscore array is equal to r.reshape. Whatever you want to reshape it on, if I pass like this 2, 3, and if I just print reshaped array, okay, and run this, did I just convert my original array into a different array format? Did I do this? Did I just reshape the array into a different format? Okay, let me show you one more example. Array.reshape of, if you add the number -1, 2, what happened in the original shape of the array to this? What does -1 do? What does -1 do? Let me explain that clearly for you. What is the concept of -1? Why do you use -1? No. Listen. In NumPy, if you are not sure about the shape of the array, meaning if you don't know whether the conversion of the shape will happen properly, meaning you don't know if the conversion of the columns or the rows will happen properly. So first of all, when you say 2, 2 is what? 2 is the row order. Agree? 2 is the row order and 3 is the column order. Is this clear to everybody? 2 is the row order, 3 is the column order. If you're not sure about the row order or the column order, you don't know. You just want to make sure that the row should be 3. Because tell me one thing, depending on 1, 2, 3, 4, 5, 6, if I take one more number called 7, can this happen? Will the answer pop up 7? No. But because you don't know how many numbers exist, even number or odd number, I don't know. But if I do it like this, what happened? Array.reshape cannot reshape array of size 7 into shape 2 because you have given the column order 2. Yes or no? Agree? If I cross and put -1 and -1 here, it will still not be able to do. But what if I do 7, 8, right? And if I come over and do it like this, okay, let's change this to maybe 3, right? Give me 1 second. 1, 2, and 3. What happened here? -1, 3 cannot reshape an array in the size of 8. 8 values, can it have some number of row which we don't know, but 3 columns? If I change this to maybe 2, 1, 2, 3, 4, 1, 2, 3, 4. But automatically, did I tell it how many rows it wants or how many rows it should have? But did it do it automatically? At the same time, did it convert the dimension from 1D to 2D? Just like that, how many number of data point does X have? Do we always know? Will we always know the size of the X? No, because we don't know. And also we want no errors and we want to convert it in 2D, always put -1, 1. So have I put only one column and one row, which automatically gives, but in 2D format. So this is reshaping the whole array. So what did we do now, right now? Did we reshape the array? What if we have more than one feature? So do we have to make all the feature into 2 dimension? Always. Does not matter you have 100, 200, 300, 800 features. It will always be 2D. It should be nested array. It will be nested array. Does not matter. It has to be 2D. Otherwise, sklearn does not consume this. Are we clear until here? Are we clear until here? Now that we have reshaped the array, if I take it like this, x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test. Call this method called train test split. And inside this, pass the value of x and y. Okay, so the values of x and y, you can pass inside it directly. At the same time, I can say test size is equal to 0.20. What happened here is, did I import a method, a function called train test split here using the library called sklearn.model_selection? Am I using the library's method called train test split? I am. I have just called that particular function here called train test split, and I'm passing the original value called x and y. And I'm taking the 100% of the data, but for testing, how many percentage will I use? 20%. If I make this 0.30, how much percent will this be? So training will be how much percent? Training will be how much percent? 70%. Testing will be 30%. Tell me, how much will be the training percent now? Did you get it? What happened? It automatically, this function called train test split automatically calculated the value of x train, x test, y train, y test in the data and gave the test data set to be 25%. Are we clear? I'm going to keep it only 20% and split the data. Also split the data. So did we get the value of x train, x test, y train and y test? Just what I taught you a while ago. Run this code. Your answer is done. That's it. That's all you had to do. The concept I had to take was so long, but it happened in one single line. Done. Now you want to implement logistic regression. Okay, some random and nums. Okay. Return nums. Okay. Okay. Some random of 1,2, 1 minute रुक जा हाँ just give me 1 second 1 2 3 4 5 6. Okay, or I can do this. Okay, I can do this. Some random function of a comma b. Okay, return a plus b and return a minus b, return a into b and return a divided by b. Okay, मैंने एक function लिखा है. I wrote a function called some random function. ठीक है? In front of you. If I call this function called some random function, and if I pass in the number 4,5, is it giving me 4 different answers? Can I say that addition is this, subtraction is this, addition is this, subtraction is this, multiplication is this, and division is this is equal to some random functions, and I will pass the value of 4,5. If I write the addition, 4 plus 5 is how much? 9. Subtraction कितना हुआ? -1. Multiplication 20 and division in Python. Yeah, good. No, you got what I'm trying to say. And write functions that can return 4, 5, 6, whatever values. This function called train test split is returning x train value separately, x test value separately, y separately, y test. So when I wrote all the variables, each variable got its own answer. So did we take the x train value, x test value, and all of that stuff? Okay. So I'm going to take linear regression is equal to linear regression. Did you all implement something called classes and functions in Python? I am using something called object, a variable LR is equal to linear regression, and I'm calling a class called linear regression. I will use, or I will tell the Python program that, hey, I'm using a variable called LR. It is nothing but my model. Your model, your machine learning model is called what? What is the name of the model? LR. But what have I called the variable name? What have I called the variable name? LR. So I will tell the model that take the model, dot fit it. What do you mean by dot fit? Run the model. But will it run now? No. Because did I pass the train data? No. Did I pass the Y train data? No. Now it will run. Now I have passed the data, it will run. Do you see this blue color box in front of you? This blue color thing? This shows that the model has run. Your model has run, and the name of the model is called what? What is the name of the model? LR. You can give it whatever you want. I have named it as LR, and your model has run. Are we clear? Your linear regression has run. Now, I want to know how my model performed on the testing data. So I will take another variable called ypred equals to, don't you want to make prediction on the test data to compare? What is the name of your model? LR dot predict. LR dot predict. This dot predict comes from sklearn only. You don't have to program it, it comes predict. So will I give it all the values of y test? Because all the y test value will tell me what is the y predicted value. No, you can't do that, because y test is for comparison. You need to give it the value of x test for it to give you the value of y test, which is y pred value. So I need to, rather than x test value, I need to give it the value of x test. Now I have all the values of y predicted calculated for me. See, the values of y predicted values that the model has calculated for the test data is now created. So basically, I have created one more column called ypred in front of you. It's right there. Agree, disagree? Now I want to know whether my model did a good job or a bad job. So can I say R2, R square is equal to R2 score, R2 score of what do you pass inside it to compare whether your model did good or not? Won't you pass ypred and y test because you want to compare them together? Y test and ypred will be passed to see how good they are, how close they are to each other. Yes. So tell me, in the R2 square, will I say y underscore test comma y underscore pred, and we will get some answer R2 is equal to 0.71? Is the model closer to 1 or farther away from 1? Closer. So did our model do a good job in prediction? Is our model doing a good job in prediction? 100% it is doing a good job. I will show you how it is doing a good job. Plot dot plot. Inside this, I will pass x test comma y test value. Just the x test value and the y test value comma. You can take whatever color you want. So let me take color is equal to black. Okay, BLACK. And the label that you can give this is the actual data. Okay, the actual data point. Plot dot plot, because you want to also print your x test value with the y pred value. I'll tell you why. Okay, I'll tell you why. X test value with your y pred value. What will this give me? X test comma y test will tell me the actual data point. X test with y pred will tell me the predicted data point. So I will say color is equal to, I don't know, you can take red, black, whatever you want. I have taken red. Label is equal to predicted value, right? Predicted value. I have taken two different plots and I'm going to run this. Okay. I'm also going to give you, give me 1 second. Did I make a, tell me before plotting, uh, what should you make sure for? Your x test and y test value are scatter plot, not an actual plot value, correct? Yeah, this makes sense because this is the data point that I wanted to plot. This data point, the black color line that you see, the black color dots that you see, that is your what data point? So if I plot dot legend, okay, plot dot legend legend. Okay, if I do this, what are the black dots? Oh, you can also do grid. You can also do grid. Plot dot grid, and inside this pass the parameter bool called true. Yeah, plot dot grid. Let me make the alpha as 0.3. Yeah. The black points are the actual data point and the red line is the predicted line. Yes or no? Do you see that the fit is good? Are we able to see that the fit is good? Please listen to me carefully. Listen to me carefully. The machine learning model has learned from so many different data sets that if your head size is 3777 centimeter cube, how much is the weight of the brain? 1282 grams, meaning 1.2 grams, 1.2 kg. Agree, disagree? Yes or no? Sir, I want to give my number. I want to give my number. I want to give weird number. I want to know if my machine learning model is able to predict my number or not. If you want to do that, use only one function, lr.predict. Now, you know that machine learning model like sklearn can only take a two-dimensional data. So give me a number like this, like if the head size is 4177 centimeter cube, the answer is 1590. Give me a number like that. I will make the prediction in front of you. 6000. 6, 1, 2, 3. What answer did I get? If your head size is 6000 centimeter cube, what will be the weight of the brain? According to the linear regression model, it will be 1883 grams. If you want me to give 4123, 4123, what answer did it give? If your weight is 1406, it is 4123, it's 1004. We did take that. Did we not take all the values of X test here and we calculated Y pred? This is how we took, right? Did we not take all the X test value and created Y pred value and then compared Y test with X test? Now you got the concept. We took the values from the model itself and we tested how good it performed from the original data. And that's why the answer of R square came up to be 0.71. Can we try 377? Oh yeah, 100%. See, 3777. What is the answer? 1282, correct? 1282 is the answer. See, look at this. 1318. Is it closer to 1282? You got what I'm trying to say? For the answer 37777, see, look at this answer. 3982. What is the answer? 1375. Okay? 1375 is the answer. 1375 is the answer. The prediction is 1370. You understood what happened? The R square that I made you do was from scratch. The R square that I did teach you was from scratch. Will you be implementing things from scratch in life? No. You will be using the function that is being called here. Can you see I have called a function called R square? You don't need mean square error now. R square. Do you see I have used this R square? That's it. That's all you need to implement. This is the machine learning code to predict whether somebody's weight will be given or not. How many lines of code minimum did we use here? Not even 10, 15, maybe 12. This is the power of Python. This is the power of abstraction. You don't need to worry about anything. Everything else is taken care by itself and you're able to use the library and build your machine learning model. Some of you were asking me question, but sir, how will we predict? How will we predict? Did you see? Call the model and call the method called dot predict and you will be able to get the answer. Are we clear? Did we get the concept? Is it clear until here, everybody? How did we learn the machine learning code and how did it implement and how did we write it? Okay, okay, good, good, good. My question to you is very simple. If we take one value from X train and it should predict exact Y train because we feed the value. What I taught you doing the concept of machine learning using actual prediction code was from scratch for your idea. But this is how you actually implement. Can you explain about lr.predict? Okay. Y is equal to mx plus c is the equation of the line. Agree? Some value of m must be calculated like 0.8. Some value of c must be calculated for 9. So won't the lr.predict do nothing but the actual value of y will be 0.9, 0.8 into what is the size of the head did we take? 3982. So it will take 3982 plus some value of C, 9 will be taken. That's why the answer came up to be 1370. Did you understand? LR.predict is doing nothing complicated. What it is doing, it has created some equation called y is equal to mx plus c. It knows the value of m, it knows the value of c. The minute you take 3982, it is able to calculate the answer 1370. This is what this function is doing. This is what that prediction is doing. Same code can be used for Swiggy. This code is reusable wherever you want to use it. Is it also fitting best possible line? Yes, Ravish. The model fits the line to the best of its abilities and then it gives the answer. Are we clear? It will automatically do all of that for you. Linear regression code runs that and gives you the most optimal answer. Don't you see the line passing through exactly in the middle, meaning the most optimal way fits? It's not even off by certain points. So it does. Because you had question in reshape, my dear, if you want to convert a data or any dimensional data into two-dimensional data, one-dimensional data into two-dimensional data, dot reshape. When you want to reshape your answers into something, you have to first pass the row and then you have to pass the column. Are you clear? The two will represent that create an array of size 2 and the answer 3. May you share the data set? Answer the row value and the column value and it will reshape the answer. The concept of -1 is you don't care about how many rows it will form, but you for sure want only two columns. And I want NumPy to take care of how many ever rows it will give me, you give me. But I want only two columns. If that happens and you don't care about how many rows will form, just put -1 there. Can you guys do some research and on the same data set print the value for adjusted R square? The answer will be same, by the way, because one feature, one target. But still, will you give it a shot? Will you guys give some try? Okay, let me tell you something. Do you think 2 hours of machine learning with me is more than enough for you to learn machine learning? I don't think so. This is possible forever. Don't you think you want to do your own research sometimes? Maybe validate whatever I teach. Hey, is Rudra teaching correctly or not? I want to check. He taught me linear regression. Let me learn linear regression from somewhere else also. Oh, no, no, no. Rudra is correct. Should you not do this? Should you not validate? You should not have faith in me. Make sense? You should always get it validated. So don't you think whatever code I taught you, you will implement it on your own. Also print extra value like R square, adjusted R square and see if you're getting the answer. Do your research. If you guys are incapable, I'm not going to say incapable, but if you have a problem, let me know. Can we look into examples where multiple features are invoked? Sure, Reena, if you want to do that, I can also do this. Since it's almost 9, I will take care of that example also. But it's not going to be very challenging, Reena. You will understand once. I mean, not multiple, like I can take hundreds of columns. It's not going to be a very complicated thing. Why don't you give it a shot, Reena? And let me know if you face any trouble. If you want to implement machine learning algorithms, right? I have a folder created for guys like you. If you go to my GitHub page, right, you will find a repository called ML codes, right? In this ML codes, you will, under the ML folder, you will find something called linear regression. See here, how do I teach you? Yeah. Can you see multivariate linear regression? Can you see? I'll show you the example. See, do you have area of the house, bedroom of the house, age of the house, and price of the house? Is it multivariate, meaning multiple features? If you go to my code, look at what I did. Listen to me. Just have a look at this data. Is this the bedroom? Yeah. Do we have this equation? Listen to me carefully. Do I load the data? df is equal to df.read CSV? Yes or no? df.read CSV. I'm going to zoom it. Yes. Okay. Do I have something called linear regression is equal to regression.fit? Can you see? Regression model dot fit, but I am dropping price as the part, meaning I am taking area, bedroom, and age in my regression model, but my y variable will be what? What will be my y variable? My target y. That's it. You just have to do regression is equal to linear model. X will be equal to area, bedroom, and age, and price will be separate. Now, what did I do? I run the coefficient. See, I'm doing regression.predict. If my house is 3000 square feet, what is the next thing? 3 bedrooms and 40 is my age. What will be the price? 49 lakh, sorry, 4 lakh 98,408 rupees or dollars. Did you get the idea? See, I'm able to predict also now. Did you get what I'm trying to say? Here, what I did is I have just dropped y variable because I don't need y variable. In X, I have taken both area, bedroom, and age. Doesn't need to be in caps. It just, you can do it in small also. Can I confirm my understanding? There are R2 here, test train, and they indicate the line is best fit or not. But none of them tell us that we have selected all the right features or not. No, that isn't feature selection. Kishle Sinha, that's different. That is using chi-square and different techniques to validate that. That is not taught by R square. R square tells you how good the fit is. But data can have null values as we are working on data before data cleaning. Will the ML give issues? Yes. If your data has null values, your answers will be wrong. Fortunately, whatever data I'm teaching you today with has been cleaned with any null and none values. So you don't have to uh, worry about it having null or non issues, right? So you see, gender has no null value, age has no null value, head has no null value, and brain weight has no null value. So basically, if you run this method called data.isNA.isNull anything.sum, it tells you the null values. It has zero because I cleaned it before for you. Because I'm thinking first you guys should learn how an algorithm works. Then slowly we'll go to EDA, make the data, clean the data, fix the data, mend it, and then we will do implementation of that. Everything happens step, step, step.